go. Barcode, yours is not working. Can you just give in the trial later, because sometimes there is a delay as well. Barcode. Good. So this is how you open the LMS system first. The link what I just send it, copy and paste and go. Yours is working. Good. So just to give a time, sometimes the link is not really working properly, but give a time for that. Good. Sorry for this mess before we just starting the classes. However, good afternoon, everybody. This is the second meteorology classes with me. My name is Angie, and my real name is Hyo Young No, but it is very hard to pronounce as I am using Angie as well. And again, I'm just saying this one. If you just guys doesn't understand during my classes because I speak a little faster, please do let me know or stop me, and then I'm gonna explain again, and then I'm gonna keep it in mind again that I need to slow down. So let's just go for this flight. Today it is gonna be in the second time of the meteorology classes. So I hope you guys study what I just asked you to study before, which is the grounded lesson, the weather theories, and the weather information, or the FAA book, which is the pilot handbook about the aviation knowledge. And there is also same chapter you can just study as well. Today we are gonna study about you are gonna starting with the humidity and then dew point as well. Humidities, as you just see in the presentation, there's two humidities. And one is absolute humidity, and the other one is, another one is a relative humidities. Just wait a second, sorry. Okay, so absolute humidity and then relative humidity. Absolute humidity is the weight of the water vapor in unit volume of the air, usually expressed in the gram meter scales. However, this is just showing the how many water vapors or humidity we have. Actually, it is not really important for us. As for the pilot, the relative humidity is more important. Relative humidities is the air parcel, how many water vapor we have it, to the total amount of the moisture the water right now can hold at this temperature. Again, so because it's just showing the water vapor contents to water vapor capacity. So actual amount of the water or actual amount of moisture to total amount of moisture the air can hold at this temperature. So relative humidity is actual amount of moisture right now to total amount of moisture the air can hold at the temperature. Why it's getting a little complicated? Because it depends on the temperature, the air parcel can hold a different amount of the water. So let's just go for like if it is if the temperature is getting higher, if the temperature is warmer, the distance between the water, the moisture is getting wider because the air is heated and it just wanted to spread away. So the distance is gonna be getting further. So moisture can just go in between over there. That's why it is different. So if the water is getting warmer, it can hold more moisture. So if you just go to those kind of equator area, which is hot and around that area, if you just go the area, same temperature, and you feel like it is really humid. And that's why, because the water is hotter and then it can just water can just volume of the water is can volume of the air is getting expanded, so more water, more moisture can hold it in between over there. And so how do we know what is the relative the humidity? Let's say there is a one water parcel at, let's say it is 25 degrees. It's not really important. 25, and then there is a rooms. So 25 degrees of the water parcel can have in the 8 moisture. And then if you just come to the Read again.
So hi guys, it is Andre IT. I'm sorry for the error and I hope this was the last time. Enjoy the rest of the class, guys.
Thanks a lot.
We hope so.
I hope so too. I'm sorry, guys. I have a problems. Dear on me. I am struggling here. What about me? I am really sorry because I just keep kicked out in the internet. It's good. Okay, you guys can see me and can see my whiteboard. Very nice, my handwriting. And oh, where was it stopped? Because I couldn't see the in monitor, so I'm not so sure where you guys stopped hearing me.
I think that we were just trying with the very first water parcel square at
Okay.
25 degrees.
Good, thanks a lot. So first the scare, okay. Because I was keep going in. Okay, so relative humidity, it is the actual amount of the moisture to total amount of the moisture the air can hold at the temperature. So I just repeat it again. If the air is warmer, air passes, the volume is getting bigger, so more moisture can hold it. So if you just go to the warm area, actually you can just be more humid in the cold area because actually the air can hold more moisture in it. So this is my example. If it is just comes to 25 degrees Celsius, the water parcel can hold in the 8 moisture. And if you go to the 15 degrees, it just reduced to the 6 moisture, it can hold it only. So if you just come to the, let's say 5 degrees, it can hold in the 4. And if you just come to the 0, let's just say that there is only 2 room for the moistures as well. So now when you're just talking about the relative humidity, it just comes to be, it's gonna be related to the dew point. Dew point means it is the given temperature degrees, given degrees is the temperature at which air cannot hold anymore. So dew point is the place at the degrees where the air cannot hold the moisture anymore. It's gonna become the visible moisture. It becomes saturate point. We call it saturate point. So what is that mean? It just comes with the scale. So now 25 degrees Celsius, I have in the, let's say I have in the 4 moisture. So it means the total amount of the moisture the air can hold at this temperature is 8, correct? The actual moisture what I have is a 4. So my relative humidity here is a 50%. This is easy so far. This is my water, moisture. I'm sorry to confuse you because I keep saying water. It's a moisture. So I have in the 4 moisture and 25 degrees Celsius. At 25 degrees Celsius, at this example, can hold the 8 moisture. I will go up a little more. So I have in the room for the 8, but total, actually I have a 4. So it is 21. So it's a 50% of the relative humidities. This one is clear? Easy? So my relative humidity is a 50%. Good. So now it just comes to the, so now somehow this air parcel goes up, or we just reduce the temperature, whichever it is fine. In this moment, the air parcel is become 15 degrees. When the air get cooler, there is a less space for the moisture. So now it become only 6, but my air still holding the 4 moisture because there is not going anywhere. So it means around 67% of the relative humidity. It's because we decrease the temperature. So my relative humidity is 67% only because temperature is changed it here. So now it become 4. It become 5. So there is a 4 room. I have in the 4 moisture. So now it's a 4 to 4. It become 100% relative humidity. And this is the point, we call it dew point. from this temperature, air cannot hold the moisture anymore. Whichever it is, just either you just pour in the more moisture, or if you get colder, now it can't be holded anymore. It's gonna become visible moisture. It can be rain, it can be fog, it can be cloud, whichever it just become the visible precipitation. So this is the point where we have in the dew point. The degrees which the air cannot hold the moisture anymore. Clear, guys? So if the 5 degrees is the dew point, so if we just go more, air is just going higher more for some uplift force. In these cases, air cannot hold it anymore, so now it just start to cloud, or it just start to have a rain or snow, whichever it is the precipitation, it depends on the temperature of the environment. So this is the relative humidity, and this is the point where we call it dew point. This is the very good questions, Mr. Alexander. That is the reason why dew point can never be higher than temperature, because it doesn't make sense. Maximum, it can be equal. In this case, if it is equal, it means on the ground you are going to see already precipitation. Or it can be either equal or always lower than the temperature. If you just study the ATIS, if you open the meta service, and the next lesson you are going to learn with Mr. Tomasz, you will see that dew point is never be higher than temperature. If it is equal, you will see. Okay, good, you understand that. So that is the dew pointed, and then relative humidities. Good. So before we're talking about the atmospheric stability, this is the forms we have in the air. So first we just have in the solid, which can be in the ice, things. If you just want it to go to the liquid, we call it melting. From liquid point, if you want it to go to the vapor, the gas type of the air, the moisture, we call it evaporation. It's just a terminology, right? I'm just introducing the terminologies. And for somehow, because of the drastic temperature change, it's become the solid to the vapor. That one is a sublimations. And from the vapor pointed, from the gas, if you just become the liquid, it's a condensations. I think when you really in the hot weather, sometimes when you just switch on the AC, immediately when you just switch on the AC, you can just see like in the fog or the cloud is coming out from the AC because of the heat. That one is, we can just say the condensations. And from the liquid, if it becomes the ice, it means it is freezing. Because of the drastic temperature change, when you just from the gas to the solid, without the liquid status, we call it depositions. This one, theoretically, you just need to know the terminologies as well. Melting and evaporation and freezing, actually, it is easy. But the one who is not really used to listen to this sublimation, condensation, and deposition, kindly just take in the snapshot and then remember. Good. So when you're talking about the stability of the air, and when the parcel of the air rises, it cools down, because when you just go up, it cools down. When you just go higher, temperature is going down. It's because of it when it cools down as well. But before we talking about the average temperature lapse rate and saturated air lapse rate, perfectly dry air lapse rate, we need to talking about the adiabatic coolings, which is, I don't think so I have presentations. Okay, so adiabatic cooling means when water, there is, let's say it is water, the air parcel. This is the air parcel. when the air is, this balloon of air is going up, the temperature is decreased. It just becomes the 15 degrees Celsius, let's say. And then when it just go up at 1,000 feet higher, it becomes 20 degrees Celsius. And then if you just go to the another 1,000 feet, it becomes 9 degrees Celsius. This one, we call it adiabatic cooling.
Is it not the same as when you're increasing your altitude that the temperature drops by 2 degrees every 1,000 feet?
No, that one is different because this one is kind of balloon, which is it doesn't have any interaction with the outside temperature.
Okay.
So that's why we just call it adiabatic cooling. Because when we just talking about the weather, the air parcel, we just said it is kind of the balloon things. So, and then the one you just talking, I think it was Miss Breyer was talking about that one. We just talking about the environmental lapse rate soon. So if it is a perfectly dry air or non-saturated air, so it doesn't have any that much moisture inside. When you just go up, it becomes 15 degrees, 12 degrees, and 9 degrees. So every 1,000 feet, it lost in the 3 degrees Celsius. Because this is, we call it dry air or non-saturated air parcel. Saturated. Because I'm sorry, it's very hard to write it over here. Non-saturated air parcel. If it is a saturated air parcel, so now it has a lot of humidity, so it's saturated. When you just go up every 1,000 feet, seriously. Today, everything just making a little hard. Okay, when it is a saturated air parcel, when you go up, it just reduced minus 1.8 degrees per 1,000 feet. Why is that? It's because when it just goes up, if it is just saturated and it becomes the gas. So when the liquid it's become the gas, it's gonna be release the heat because from the gas, from the liquid to heat, you need to release the heat. So that's why it's just getting the less temperature decreasement compared to the dry air as well. Quickly, I just coming here. So saturated air, it just cool down at the rate of the 1.8 degrees Celsius per 1,000 feet. So it becomes minus 1.8 degrees Celsius. When you go up to the 2,000 feet, it becomes the minus 3.6 degrees Celsius. So every 1,000 feet, it's going to lose the 1.8 degrees. If it is dry air or non-saturated air, it's going to cool down to 3 degrees Celsius per 1,000 feet. So when it is in the 1,000 feet, minus 3, when it just becomes the 2,000 feet, it's going to lose the minus 6 degrees Celsius. It is different with what Ms. Breyer is asking me about the standard temperature. That one is this one is talking about the air volume. So the one Ms. Breyer was talking about was in the average temperature lapse rate. This is environment temperature lapse rate, which is 2 degrees Celsius per 1,000 feet. But this is the theoretical temperature lapse rate because we just wanted to have in the standard. But this saturated air and perfectly dry air and this one, it is just a value I fixed it. It is just ideal things we are talking about when you're just talking about the theories. Saturated means it's a full moisture inside. Non-saturated means it's a dry air. Saturated air means it is 100% fully, water moisture is fully maximized inside the water parcel. Yes. Why we are talking about this one? Because we are going to talking about why the cloud is formed. So environmental lapse rate can have any value. Environmental lapse rate means actual one. And it can be, of course, it can be deferred to any value because our temperature and our environment is nothing about, it's not really like in the theories, right? It's always different. It depends on the wind, depends on the temperature, depends on the pressures and different water systems. So it's always changing. When you just see this one, environmental lapse rate is less than 1.8, the air is absolutely stable. It's not gonna make sense anything right now, but I'm gonna explain to you. And environmental lapse rate is between 1.83 degrees Celsius is a conditionally stable. And environmental lapse rate more than 3 degrees Celsius is absolutely stable. So now I'm gonna explain to you what it is. So let's say it's a 1,000 feet, 2,000 feet, so one is the ground, 1,000, 2,000 feet, and 3,000 feet, and let's say 4,000 feet, and 5,000 feet. And environmental lapse rate, today my temperature, could you full screen the whiteboard? Actually, this is my full screen. Can I do something else? Can you see this? Let's say my environmental lapse rate, today my temperature is less than 1.8 degrees Celsius. Environment lapse rate. What does that mean? Let's just starting from the 15 degrees Celsius. So 15 degrees Celsius, I was in the ground 15 degrees Celsius, and then because it's 1.8, it's hard to just calculate it, so I will just do the 2 degrees around. And then 1,000 feet, I become 14 degrees, 13 degrees, or maybe I will just doing I will just keep going on like this, 12 degrees, 11 degrees Celsius, and 10 degrees Celsius, because this is environment. It is nothing about the theory. It is my actual things, actual temperature. So now on grounded, I have in the one warm air parcel. This is my air parcel. And this is the unsaturated or dry air parcel. It was a 16 degrees Celsius. So now 16 degrees Celsius, the water parcel, it is lighter than the ground temperature. So water parcel is gonna be rising up because it is warm. So, but however, since this is unsaturated or the dry air parcel, every 1,000 feet, it's gonna be reduced, decrease minus 3 degrees Celsius as per the theories. So it becomes 16 degrees. At 1,000 feet, it becomes 13 degrees Celsius as well. And then here, as for the theory, at 2,000 feet, actually it need to be 10 degrees Celsius. But however, this air parcel cannot go more anymore. It's because outside the temperature is already warmer than this. There is no lift is gonna falling up. So this air parcel become heavy, it cool down, and it just comes down again. So air is not moving up. This air parcel cannot go up anymore. It just always stay on ground. So this condition, we call it atmosphere is stable. This stable part makes sense. It's because of this adiabatic cooling, the air parcel, when it is unsaturated dry air parcel, it's just losing the minus 3 degrees Celsius per 1,000 feet. So when you want it to go up, outside temperature is already cool, so it can't go up anymore, it just goes down as well. I will explain it another one. So this is the environmental lapse rate is less than 1.8 degrees. But let's say, as for our here, the one which just showing it here, let's say environmental lapse rate is more than 3 degrees Celsius per 1,000 feet. In these cases, again, I'm gonna starting from the 15 degrees, but now it should be more than 3 degrees, so it just cool down very quickly. It become 11 degrees. And then after that, it become 70 degrees. It cool down very quickly, 3 degrees. And it become -1 degrees, like this. So my environment lapse rate is more than 3 degrees. In these cases, I have in the same air parcel, which is 16 degrees Celsius, which is unsaturated dry air. Because if it is already saturated, there's no point going up. It's going to be already making some precipitation. So it want to go up. So now it just goes up. What's going to be happen? It's 13 degrees Celsius. Because it is 1,000 feet, I lost the 3 degrees Celsius. It's still warmer than outside temperature. If it is warmer, it has energy. It want to go up. It goes up. And 13 degrees Celsius, it become 10 degrees Celsius. Still warmer than outside. It want to go up. 7 degrees Celsius. Still warm. It want to go up. 4 degrees Celsius. Still warm. It want to go up. It's going to keep on again. It's because it is warmer. So this air, we call it unstable conditions. This one, it's because today's environment lapse rate is like this. This is just for example.
Okay, and how, when you said on the top left corner, when you said the environmental lapse rate is less than 1.8, but you were just going to use the number 2 to make it easier?
Yes.
Where are you using that calculation?
No, it doesn't matter. It doesn't matter. I just wanted to use it. It doesn't matter even though if you just wanted to using in the 13 degrees, it's gonna be same. Like this. And then what is this one? And then 7 degrees, right? So now if in the 15 degree, it becomes 13 degrees. Here is 16 degrees, 13 degrees. Now it's gonna cool down again because it's almost the same. It cannot go up. Correct?
No, I understand, but I'm not sure how. I don't know which information you're using to make the calculation.
No. I just wanted to make it because I don't want to do the -1.8 because it's hard to calculate. So that's why I just said I'm gonna using the approximately 2 degrees.
Okay, but where did you use the approximate 2 degrees?
No, I didn't use it because I just do the -1 degrees only.
Okay.
I didn't do it. However, okay, now I understand what is confusing part here. So in these cases, wow. I'm sorry because I can't see. I will just come up this one again. If that my degrees is gonna make you guys confused, I will do it again here. So I say I just wanted to using the 2 degrees Celsius because it is hard to calculate it. So let's say it is here, 15 degrees Celsius. Here, I'm just using in the 15 degrees Celsius, right? And then 13 degrees Celsius, 11 degrees Celsius, 9 degrees Celsius, 7 degrees Celsius, 5 degrees Celsius. And if it is the same, 16 degrees in the water parcel, the air parcel, you want to go up. Since it is unsaturated, it becomes 13 degrees. And can it go out? No, because it's already equal. There is no energy which is going to push this one to the up. Because if it is wanted to go up, the outside temperature should be warmer than this, so it can just push up, but it can't be there anymore, so it's gonna fall down again. Disregard this 2 degrees, I just wanted to make it simpler. This is because this is environmental lapse rate, it is actual temperature differences. because our temperatures is not all the time we're using as in the standard.
So
Sometimes
the
it-
environmental lapse rate isn't something that we would calculate, it's something they
No.
would tell us.
Something we have. This is environmental lapse rate. If it is less than 1.8, the air cannot go up because it is stable. This environmental lapse rate, it's not fixed one. It is something in the nature. However, whichever is the lapse rate, if it is below 1.8, the air becomes stable. Whichever is the temperature, if it is more than 3 degrees Celsius, air becomes unstable because it wanted to go up more and more. This reference point this is the real temperature. So the air is dropping from the 16 degrees to 13 degrees because, you mean here, this one, because this air parcel is a dry air parcel. It is true. Mr. Alexander, you are correct. Why I am just saying this one? Let's say on this day, it's a 15 degrees Celsius, and let's say this day my dew point is minus, let's say it is a 3 degrees. It doesn't need to be in the minus degrees. It can be in the any degrees as well. In these cases, 16 degrees, 13 degrees, 10 degrees, 7 degrees, 4 degrees, and it become in the 1 degrees as well. I'm going up and up and up and up, and dew point is 3 degrees, which is here. My air parcel cannot hold the moisture inside anymore. So it start to having the form the precipitation is just start to out of my air parcel, and now it start to having the cloud formations here. This is how we work in the air parcel and then dew point as well. I will give you this example on the presentations. How can I down this one? Okay, finally. So now let's just see this one. This is today's environmental lapse rate. This is today's temperature. And then today's the temperature and dew point, they say it is, I think it is 5 degrees Celsius. This is my dew point today. Like this. And this is my reference. When today it was on ground was 12 degrees Celsius. At 1,000 feet, it becomes 7 degrees Celsius. 2,000 feet, it becomes 5 degrees Celsius. 3,000 feet is 3 degrees. 4,000 feet, 2 degrees. And 5,000 feet, 1 degree Celsius. It's not even the same amount of the lapse rate. It's a differ because the environment it is a differ. However, the air parcel what I have, since it is in the dry here, because it's not saturated point yet, it's 1,000 feet, it becomes 9 degrees. At 2,000 feet, it becomes 6 degrees. However, dew point is 5 degrees here. The moment we just reach the dew point over here, it just start having the cloud forming. Because this air parcel cannot hold any water moisture inside anymore. It's just now precipitation, it's gonna be out here. And then, but however, still there is a force to going up, air parcel still going up. So now it just become, here is moisturizing, and it become unsaturated air parcel, which is gonna be it's going to be lose minus 1.8 degrees Celsius per 1,000 feet. So it becomes 3.7. Still, this air parcel, it is warmer than outside temperature. You want to go up again. 1,000 feet go up, saturate air, it lose a minus 1.8, so 1.9 degrees Celsius. However, at this point now, it cannot go up anymore because the outside temperature is going to be cooler than this. So there's no power, no lift forces to push this air parcel to up. So that point is around that area, the cloud is just start forming because it doesn't have any uplift force anymore to go up more again. Kind of understand?
What is the
Environment lapse rate is not a fixed one. It's not a fixed rate or something. However, if it is just less than 1.8, air is stable. So it doesn't even have a force to push this air parcel up. But if it is more than 3 degrees Celsius, since the dry air parcel, the unsaturated air parcel is just losing only minus 3 degrees for 1000 feet. So outside the temperature have a force to lift this air parcel to up. This is what we wanted to talking about. Who decides where the dew point is every day? It depends on the weather. So this is the meteorology telling us. Meteorologist. We don't know. As a pilot, we don't know. This is the places where we're checking in the meta condition. Yes.
What is DALR and SALR?
DARR is this one. Dry air lapse rate and saturated air lapse rate. Saturated air lapse rate is a minus 1.8 degrees Celsius. Dry air lapse rate is a 3 degrees per 1000 feet. And ELR, this one is environment as well. So I will explain this one once again. My environment today is my temperature. Ground is 12 degrees, 1000 feet 7 degrees, 2000 feet 5 degrees, 3000 feet 3 degrees, 4000 feet 2 degrees, 5000 feet 1 degrees. This is the real, let's say, actual temperature differences. One air parcel on ground, here, this one, air parcel, if it is dry, if it is not saturated, it's gonna be reduced it's gonna be lose minus 3 degrees per 1000 feet. So it goes up because ELR is more than 3 degrees Celsius, so air is unstable. It wanna go up because it is warmer than outside temperature. It wanna go up. 9 degrees, it wanna go up because 9 degrees is higher than 7 degrees, so it wanna go up. So now here, 6 degrees, about outside temperature is 5 degrees. I am still warm. I still have energy to go up. I want to go up. However, this day, today, my dew point is 5 degrees Celsius. It means if there is any moisture over here, it cannot hold it anymore. It needs to be saturated. The precipitation needs to be out because my air parcel cannot hold the humidity anymore. So this is the point where the cloud is started forming. Moisture become visual precipitation. However, so now I become saturated air parcel. Saturated air parcel just losing the 1.8 degrees Celsius per 1000 feet. So when you go up, it becomes 3.7, but still, even though I am 100% saturated, still I am warmer than outside air. So I have the energy to go up because I am unstable. So it wanna go up. So finally it becomes 1.9. Now I am colder than outside. I don't have energy to go up anymore. That's the places where the cloud is stop formating. Because my air is right now it is stable. It's not unstable anymore, cannot go up anymore. This is the place where the cloud base is starting it and where we decide where the cloud top. Go back to previous diagram, is this one? So it's written here, environmental lapse rate can have any value because it's a nature. However, this environmental lapse rate, it is less than 1.8 degrees Celsius. Outside the air is too cool. I'm sorry, outside the air is too warm, so it cannot, air parcel cannot be pushed in. So air is stable. If the outside environmental lapse rate is 3 degrees Celsius more than that, air parcel is just still warm and warm and warm, even compared to the outside temperature. So it's not go up, 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 up. It is absolutely unstable. If it is between, it goes up, and then some certain point it's gonna come down again. So that's why it is conditionally stable. So air parcels stop rising at the point it becomes stable. Yes. The environment, yes, it's not going up anymore because it doesn't have any force. Saturated air rate is the beginning of the cloud. Saturated air rate means is this one? No, cloud, beginning of the cloud is the places where you're having the dew point. So if the saturated air passes, still it is warmer than outside air, still it can go up. Like this one. Where is the cloud is formed is the place of the dew point. But even though it is saturated air, if it is still warmer than outside air, it can be pushed up. It can go up because it has energy, it wanna go up. I'm not so sure, Mr. Collins, it can be answered to your questions. Good. So dew point, it is the temperature where the saturated air cannot pour the moisture inside. So now it's become the visible precipitation. It can be cloud, it can be snow, it can be rain, and it can be fog, whichever it is the visible precipitations as well. I have a
Reserve.
okay.
So I will.
I'm sorry, guys. Give me. Thanks.
See you in time. Bye bye. Any minute come by. I'm gonna pick it up now.
I'm sorry, guys, because I need to receive the key for the rooms. So air lapse rate can take any value between 1.8, depends on the percentage of the limit. The air lapse rate can take any value between 1.83, depends on the percentage of the limit. Yes, it is correct. Can I pass in this one? So now if you just see this picture, here it's just going up and up, but still, even though you just unsaturated saturated air, it is gonna be warmer than outside the temperature, that's why it just goes up. And when it just when outside temperature is colder than our air parcel, that's the time we just stop in the air, the cloud is formed. Now it just need to go down or stay there. It cannot go up anymore. So if you just see this cloud picture, the places where it just goes up, and this is the places where the air is unstable. That's why the air parcel keep coming up and up. And the point over here, the places where there is no more cloud is, it means that area air becomes stable. Or the air parcel cannot go up anymore because of the environmental lapse rate. It is corded outside. So the cloud formation mechanism, it's like this. When the sun is heating up, it's not heating up the air parcel, it's just heating up the ground. And then from the ground, there is a radiation heat. It's going to be heating up the warm air parcel on the above the ground. So don't get confused that sun is heating up the water parcel. Sun just heating up the ground. And from the radiation heat from the ground, it's going to start heating up the warm air parcel, and it goes up. So when the air is warm air above the ground, when it's just getting heated, it's going to be rising. over here, it's gonna be rising. And then when you just having this blue dot, and it's just rising again. And then when you just having the almost in the, it cannot hold anymore the water the moisture cannot be held inside the air parcel. That's the time we just having the dew point, and that's the time we are having the start having the clouds. If it is happening in the lower level, it becomes fog. Dew point would be where on the previous presentation? Here. It's a -5 degrees is the dew point. How about this area is still 6 degrees, so it can go up.
On the right picture.
Over here.
Yes.
In this case, the around should be here.
Okay.
But it can be a little different because the air can go up if it is still hot, still warm. So, but I should say around here because
Okay.
it's the start to having the saturation point.
Thank you.
My pleasure. So how do you measure the amount of the cloud? First, when you just having any weather information from the one particular airport, they are just saying that the particular airport over that area. Normally, they just say the 25 nautical mile from the places where they are taking the meteorological informations. And when they just taking this information, they just divide it into 8. And each unit, we call it octa. This doesn't have any meaning, it's just unit. So if it is totally there's no cloud at all, they just say sky clear. It's called, you will see it is SKC, sky clear. But if there is any cloud, and which they just check that, okay, this amount of the cloud on my airspaces, it's just 21.1 to 2. It just cover 1 to 2 octa. We call it few. And you are going to see the weather information like this, few. If it is in the 1 to 4, it just cover 3 and 4. It becomes scatter. It's any cloud which is covered to 5 to 7. So it's almost all covered, but there is a small dot of the blue sky you can just see. In that moment, they will call it broken. If it is fully covered, they will say it is overcast. This is the meaning, and this is how much it is just sky is just covered by cloud, and this is the information letter you will see on the meta information, weather informations. So few means 1 to octa is covered by cloud. Scatter 3 and 4. Broken, it's going to be confusing. However, it is a 5 to 7, not 5 to 6. It's a 5 to 7 here. And overcast, fully covered. You will not see any skies. That one is an overcast. And this is how you are going to see on the weather informations. So if you just come to I will just show the weather information, how it is going to be seen. Quickly. This is how you're going to see. View. It means on this Praha, when they just push all the cloud on the sky, it's going to be covered 1 or 2 octa. Can you fly VFR in broken? Yes, you can if you're under the cloud. We can't, here in Czech Republic, if it is broken and overcast, we are not allowed to go up to the cloud because we don't have any visual contact on ground. But it depends on the countries. It depends on the what kind of regulation they want to set. But in Czech Republic, no. Because we are not allowed to fly over the cloud in Czech Republic. So how do you measure of the cloud altitude? There is in the devices, devices they are gonna doing it and they just using it like this. However, there is how much you can just doing it. This one we don't need to know as a pilot. We just need to know how decoding the weather information. But there's things we need to know. Difference with the cloud base and cloud ceiling. It is related to what Mr. Steve is asking me. Cloud base is the lowest level of the cloud is located. It doesn't matter it is a few or scattered and broken and overcast. Just the first layer you will see you see on ground. You see in the air. That we call it cloud base. But cloud ceiling is the first height, the first layer of the cloud more than broken and overcast. That one we call it ceiling. So basically, we can fly over cloud base. We might be, but over cloud ceiling, no, we can't. What is the differences again with the example? So there is a ground surface and there is a cloud. Let's say this is the fuel cloud and it is 1,600 feet. And then after that, there is a broken cloud. This is the, let's say 3,000 feet. It means my cloud ceiling is 3,000 feet. However, my cloud base is 1,600 feet. In Czech Republic, we are not allowed to fly over here. We can just fly only here. Few and scatter, we can fly because we will have a visual contact on the ground. So we can maintain the VFR conditions. So this is the difference with the base and ceiling. Base is a few, doesn't matter whichever cloud it is. The first layer we are going to meet the cloud, it is the base. And ceiling, it is the first layer where we are going to meet the broken and then overcast. What does that mean? If it is like this, let's say somehow on this weather, like a long time back, we have in the overcast cloud at 1,600 feet. And as a meteorologist, they know there is kind of cloud on the top. There is also, let's say, few cloud at 4,500 feet. What does that mean? My cloud base is 1,600 and my cloud ceiling is also 1,600 feet. Yes, Mr. Steve answered yes. Always need to be under ceiling. This second example is understandable. First layer where we met is the base, and first overcast and broken is gonna be my ceiling as well. So in this second example, my base and ceiling are same.
No pilots can fly over the cloud ceiling, or only private pilots?
First, again, it depends on what kind of regulation you are flying at. I say again, Czech CAA, it is not allowed to, Czech CAA, they are not allowed the VFR flight is go more than ceiling. This is a Czech regulation, first of all. I think Germany, you can fly even over cloud, even over broken and overcast, but there is another regulation for that. You need to submit the flight plan and you need to have the transponder. It is a different regulation. And what kind of pilot can fly over the cloud is the one who can fly in the IFR flight, which is the instrumental meteorological condition. If you are rating with the IR, and plus if your aircraft is with the IR certified, and if you go to the airport which is equipped with the IR approaches, yes, you can. It is also depends on the seat. You mean the category 1, 2, 3? That one is about the IR, but I can't say it is also. It can be, yes, even if you are having the IR rating. But we are talking about the VFR flight because PPL is for the VFR. Cool. Can I continue? Ceiling and base, you understand? Yeah. So, okay. Explain the overcast. Overcast means it is fully covered. 8 octa to 8. We divided the sky in the 8 pieces. Overcast means fully. Here. We divided our sky to 8, and there is some cloud, and then they push the cloud in one places. If it is only covered 1 and 2, like this, it means it is view. Scatter 3, 4, so it's almost a 50% coverage of the sky. That's the scatter. It's broken is a 5 to 7, and overcast fully covered. Mr. Collins, if it is a sense. Answer to your questions. This is just the terminology: view, scatter, broken, and overcast. And this is how you are going to see on the weather information. So when you just see the weather information, if you see the broken 5 to 7, you will see that, okay, it's going to be hard to see the blue sky. So I need to thinking about my VFR route if I can just have in the separation from the cloud, because we are not allowed to enter the cloud. If it is 8, it means you are not going to see any blue sky. It's going to be fully covered. So you really need to thinking about your separation from the cloud, because we are not allowed to fly inside the cloud. This one? You mean this diagram? You mean this table? Yes. Actually, I don't understand what you wanted to ask. Yes, this diagram, you mean this table? 1, 2, 3, 4, 5 to 7, and 8, view, scatter, broken, overcast. So it's like this, when you have in the cloud here, because it's hard to judge, and as meteorologists, they just pushing this cloud into the one places, and they are just checking it. If it is covered 1, it means view. If it is covered 3 and 4, it means it's a scatter. 5 to 7, broken, fully 8. 8 means overcast means there is no blue sky you are going to see. Broken, you might see some blue sky as a dot, some places, but not that much. And then we're talking about the base and ceiling. Okay, so the type of the cloud, let's just talk about this one. Let's just starting from the bottom. If it is a stratiform, or we call it stratus as well. This one is for the Latin, the origin, the meaning of the origin is in the layer or the blanket. So whichever it is just cloud which just having the layer, that one we call it stratiform cloud. This is just only formation. I'm not gonna read it all. And when you just come to the cumuliforms is like in the cottons or those kind of broccoli type of the cloud. It's like a cotton shape and broccoli shape. It looks really nice and it looks very cute. And those kind of things we call it cumuliform cloud. And there is a nimbus. Nimbo means rain. So when you just have in the nimbo cloud, it is in the black or dark gray color, which has a lot of rain inside, and it can be just located between the lower level and the middle level, and it's gonna bring us in the rain or snow. It depends on the temperature outside as well. And if we come to cirriform or cirrus form, this one is already high level cloud, and it's just having since it is very high level. If there is any cloud, it goes to the high. It means it doesn't have that much moisture, and it's already ice. It's already formed in the ice, so it's just composed of the ice crystal. and it's quite really high. It is more than 25,000 feet or 20,000 feet higher. So it's not really affect us as a general aviation because we are flying, I think so, without oxygen is maximum 10,000 feet. So we don't have any that much things to meet in the cirriform cloud. It's a cirrus forms. And if I just see the pictures, I think it's going to be more clear. When you just see the type of the cloud, this is the first things we are talking about. Their type of the cloud can be divided into the positions. It's a low cloud, and middle cloud, and then high cloud as well. Low cloud is normally around ground surface to the 6,500 feet. And the middle cloud is 6,500 feet to 20,000 feet. And if it is more than 20,000 feet, we call it is a high cloud as well. Low clouds, if it is stratus, whereas stratiforms, it means it is a blanket. It is a layer. Stratus meaning it is a layer of the cloud as well. And so it's a stratus, and stratus cumulus, it's basically it is a layer, but it's also start to having this cotton shape as well. So starting from the layer, however, since inside the air still it is not stable, so it just wanted to go up as well. In that point, it can be stratus and cumulus as well. If it is a nimbostratus, it means it is a blanket type, blanket shape, and also it comes with the rain or any precipitations as well, because it can be snow as well. If it is a middle cloud, it comes with the alto. Alto means high. So again, it's a Latin as well. Alto stratus means if it's a high and stratus. So old fashioned, if it is a high, maybe it is just having the 65 and the 20,000. That's why I just put it in the high. So it means it is a middle cloud with the blanket type of the cloud. If it is alto cumulus, the cumulus type of this cotton shape or the broccoli type of the cloud with the high positions. If it is a cirrostratus, it's a blanket type. Cirrocumulus, it is just ice crystal, however, it just comes a little cumulus as well. Cirrus means it's like in the feather type of the cloud as well. But since it's already very high, it doesn't have any that much moisture inside, and then it means it is not that dangerous because it's already become kind of stable. And it also comes with this low and middle and then high. Also, we are talking about the vertical energies. How much it can go up, because the air parcel, if it is not stable and if you just want it to go up and up and up, it can just have in the cumulus, which is the towering cumulus. It's already building up like in this cotton shape, but still inside the cloud there is a force wanting to go up and up. It's getting up and more and more. It just start having the towering cumulus. So if you see the towering cumulus, not only cumulus is going to be like a cotton shape in the here and there. So you will see the bottom and the top. I don't want to say it's safe, but it is not that dangerous. But if you see the towering cumulus, it can be very dangerous because inside the cloud, there's a lot of updraft energies because this air parcel wanted to go up and up. So when you just see the towering cumulus, it's already not safe. But if this towering cumulus combining with the nimbostratus, which is the rain and then those kind of precipitation, it becomes cumulonimbus. This is what we need to avoid it. This is normally we just say in the thunderstorms as well. So inside the cloud, there is a lot of updraft and then downdraft because the air is not stable. So it's just moving inside, up, down, and still it just comes with the precipitation. And since there is a lot of updraft, the weather can be inside, the temperature can be very cold. So even the precipitation can be rain or snow, or it can be even hail. You know, those kind of the ice which is just dropping from the air, it can be those things. So as a pilot, if it is already starting from the towering cumulus, actually it is just better avoid it because inside you don't know how much updraft and downdraft is inside it as well. So like a general aviator, like what the aircraft we are flying, maybe you can't stand it inside as well. Or if it is already comes with the cumulonimbus, there's nothing you can do and you need to avoid it. Because if the cumulonimbus is just started forming with the towering cumulus, if it is inside the updraft is really severe, it can even go to the tropopause. So you feel like you can just avoid it, so you want it to go up and to flying over it, maybe you will not see the end because it's really, the top is really high. And if you're just going through inside, you don't know what kind of updraft and downdraft inside, and you don't know what kind of precipitation inside. So visibility is going to be super bad, and turbulence is going to be really bad as well. So as a general aviator, we can't fly inside as well. Yes, it can go to the tropopause. It depends on how much updraft energy it has, especially during the summertime, especially the one who is in the Europes. Yeah, so this is the type of the cloud as well. Before we go for all the clouds, let's just stop it. Let's just have a break. My watch is 6:20, and let's have in the break for the 6:30. Yes, in CD. Mr. Nikita is correct. I will just place it here because I want you to read it if you're having the time during the break, and then let's meet up. 0630. Bye. Okay, so let's just continue. And type of the cloud, we just divide it into three: low, middle, and high. And if it is just comes with the high, it comes with the zeros. And if it is the middle, comes with the R2. It comes with the low. Actually, it doesn't have the particular name for the low, but which comes with the stratus. Actually, since it is just a layer, so it's just having the low cloud as well. But the type of the cloud is a stratus, is a blanket type. It's just the layers. And then cumulus is just like a cotton shape, like a broccoli shape, but we're just seeing it. That one is a cumulus. And then cirrus is like a feather type of the clouded as well. If it comes with the nimbo, it means it has in the rain. And it comes with the towering cumulus. It means it is the cumulus type of this one, this kind of the type of the cloud, which is the broccoli and cotton shape of type. Since it is towering, so there inside the cloud, there is a lot of updraft forces inside it, so it just wanted to go up and up and up more. So it has in the vertical development as well. So this kind of towering cumulus, which comes within the nimbo, which comes with the rain, it becomes towering the cumulus nimbus type, which is we call it thunderstorms. So as a general aviator, we better avoid it because the top, it can be really go higher. It can be around the tropopause as well. So when you just see this kind of type, don't thinking about you are gonna fly over. You either fly around, which is quite far away. Normally they just said that when you just see the towering cumulus or the cumulonimbus, it's just gonna affect in the 25 nautical mile away from the clouded as well. Or before you go in, you just need to let it and then wait until it got past. Because since it has a lot of energy, it can dissipate it also quite quickly as well. So this is the one thing. So let's just quickly go through the what kind of cloud we are gonna expecting. Let's just starting from the high cloud as well. If it is a high cloud, altitude is quite high. It is more than 20,000 feet. And since it's already high, then the outside temperature is already very low. So actually it is already become the ice crystal. But there is a force to hold it, so it's just there as well. And normally it just comes with a quite nice weather. So there is no turbulence. There is no icing expected that much. And visibility is quite good, as you can see. You can see more than that, right? And which is quite high as well. That's the cirrus, which is a feather like in the cloud as well. If it is a cirrus stratus, it's like since it is a cirrus feather-like layer, and also altitude is very high, and you're not gonna have any turbulence and icing. Visibility is good as well, and it already comes with the ice crystal. So when you just meet in the cirrus, actually you don't need to worry about that much. But as a general aviator, we don't have any that much chance to meet it. And if it is a cirrocumulus, it's the same as like this. Turbulence, since it become cumulus now, there is gonna be, maybe there is no turbulence, maybe there is very light turbulence. Since there is some updraft of forces as well, that's why it become cumulus. Otherwise, you don't need to worry about that much. If it is a middle cloud, so it means it is R2 cumulus. R2 means high, however, we just say in the middle cloud, which is 6,500 feet to 20,000 feet. And its altitude is getting lower. It's between 6,500 feet to 20,000 feet. And so now it's getting a little lower. So it can be mixed with the water droplet and then ice as well. Because outside temperature, it can hold both. And turbulence, it can be there because it is a cumulus as well. So light to moderate. And there is an updraft force and there is also moisture inside, so there is icing can be happen. It can be in the light to moderate, and the even turbulence can be light to moderate turbulence as well. Visibility, if it is not really inside the cloud, it's gonna be okay. And then location, one front, this one I'm gonna discuss it about later. And then artostratus, this is what you are going to see, middle height with the blanket shape. So this is kind of a suffix and then type as well. Artostratus as well. And altitude is a middle, 6,500 to 20,000. It's again composition is water droplet and then ice crystal, turbulence and icing light to moderate, and visibility is still okay as well. So this is the things we are, as a general aviator, we are gonna encounter from now on. It's a middle cloud and the low cloud as well. If still middle cloud, if it is a stratus and altitude is there, still it just become the layer and then it is quite low. So now we don't have any ice crystal yet, and then we are going to still having the water droplet. Since it is a layer, so there is not that much of the turbulence because it can be beams, but icing can be possibly happen. Why? Because inside the cloud, it is water. However, when aircraft is flying into those kind of water, if you guys remember, when the leading edge of the wing, because of the stagnation point, the pressure can be very low. When the pressure is low, temperature is lower. So it can start to having the foam, the ice on the wing area. And even in the elevator, our fuselage basically. So icing can be happen because there is a water droplet and the aircraft flying fast inside the cloud. So we just need to start to be careful. And visibility can be medium to poor. We can't see that much because of the thick layer of the water moisture, because the rain inside or precipitation is inside. And it can be turbulent cloud and the warm sector and fog as well. So now if it is a stratocumulus, it's a lower altitude, water droplet is gonna be here turbulent, and icing can be there because there is a water vapor and there is an updraft and downdraft as well, and visibility can be poor because of the cumulus and because of the precipitations. If it is a nimbostratus, so now there is a precipitation, it can be heavy rain or it can be heavy snow. There is a full of water inside as well because it comes with the nimbo. So it can be compositions, water droplet, ice crystal, and the higher altitude. Higher altitude means the higher altitude of the cloud. And turbulence can be there, like to moderate. Icing can be moderate up to severe because it is full of moisture inside as well. So more moisture, if you just go faster, you can have the more icing on the fuselage as well. And visibility can be poor because of the precipitations inside. And the location near to before the warm front, this location we are going to discuss about later. And this is a different shape of the cloud. And another cloud is a cumulus, which is a cute, fluffy one. However, it looks cute, but since if it is a cumulus, it means it's just coming up. It means there is a draft, updraft. There is air passage moving, keep moving up. So turbulence can be severe. If you think in that way, it looks cute, but turbulence can be there if you're inside the cloud as well. So even though you are instrumentation flight, even though you're having the IR rating, if you can avoid it, it's better avoid it as well because it can be severe. And icing even can be happen since it is cloud, there is a precipitation inside, and if you go faster, again, you can just have in the icing as well. And inside the cloud, the visibility is poor as well. So this is the things we always need to avoid it, which is a cumulonimbus cloud. In the weather conditions, you are gonna see this one, CB, in weather information as well. Altitude can be lower and then can be very high. It depends on how much energy it has. Composition, it can be super cooled water droplet and then ice crystals as well. And the turbulence, severe up to extreme. Maybe general aviation, maybe we can't hold it inside because of the updraft and downdraft as well. Icing can be very severe. Visibility is going to be very poor. And significant instability, thunderstorm, lightning, heavy hail, and heavy precipitation, whatever you just named it as well. This is the one we always need to avoid it. So imagine if you're just flying like this, if you just see from the behind, it's good. We already see what is the top, so we know that we can't go up. But sometimes this thunderstorm can be embedded, like it can be hide behind any kind of cloud as well. So because of the cloud which is in front, maybe we can't see the top. So if you just have this kind of information, the weather information, you better terminate the flight or you just land until it got past and then waiting for it. Don't risk your life. So let's talking about the fog. And fog, it is a type of the low cloud in the around the ground area as well. So it's almost the same as in the how the cloud is forms, and so warm air over the cold ground of the water and cool dry air picking up the moisture, and there is a radiation fog and the advection fog as well. So I will just briefly explain to the how what kind of fog we have it. So fog is a cloud. It's almost the same. Cloud in the low, on the surface area, and how is just happening when you just ground it here, and then warm the air parcel, it become cool down very quickly to the dew point. In the cases air, this air is become condensed, it become visible moisture. It become visible. So that's the time we have in the fog. So if there is any draft in this moment, if the, somehow this fog is pushed up to in the air, it becomes cloud as well. However, cloud and fog, it is almost the same, but just near to the ungrounded as well. There is a different fog. First, we call it radiation fog. Radiation fog, it just happens when night is clear. There is no cloud. So when it is a clear night and then there is no wind. No wind. Why is it happening? There is a ground, and then the ground there is a water pass, the air parcel is on the top of it. But since there is no cloud and nothing, and then when the heat was on the ground, it's gonna losing the heat very quickly. So since there is no cloud on the top, heat just goes to the air. It's not holding any places. The ground cools very quickly. When it cools very quickly, if there is any warm air on the top of it, it just starts condensing at the bottom because of the ground cools very quickly. So it's going to be very shallow fog, the radiation fog. Normally they just say it is just around the 20 feet thick only, and air become very cold as well. And once next day, when the sun is rising and it just starting heating up the ground already in the morning, it's going to be dissipating. So that's the radiation fog. It needs to be clear night, so there is no cloud and there is no wind. So this air pass is not going anywhere, it's just remaining. But since the ground, the land area cool down very quickly, it's gonna start condensing at the bottom of the air parcel and it become fog because it meet the dew point. That's the radiation fog. And once the sun is rising in the following day, it's gonna start to heating up the ground quickly. So it's gonna push up this warm air is going up. So the radiation fog is gonna be dissipating very quickly if the following day has in the sunny days. And second, we call it advection fog. Advection fog, it need the wind a little bit. And then why it is the happenings, and then there is the ground and there is a, let's say it is just having the like a water, any kind of water. It can be ocean or it can be lake and it can be river and then whatever it is, and there is a warm air on the top. And wind is blowing. So this warm air over the water, because water is just holding the heat more, so it's gonna be still warm. But since this wind is pushing this parcel to the ground, and ground in the night, ground is already cooled down very quickly already. So when the warm air just started meeting in this cool land area, it started condensating. It started having the condensation. So because of this air pass is just moving in, fog is just happening above the ground. And this one, we call it advection fog. What is the difference with the radiation fog and the advection fog? Advection fog need in the water and it need the wind. But wind, how strong wind it is? Around, they say that normally it is a 15 knot less. Why? If it is, but there need to be wind, like a light wind need to be there because this parcel need to be moved it. However, if the wind is too strong, this parcel is going to be dissipating. So it can't be held over here. Or sometimes you just push to the up. In that case, it's going to come to the stratus cloud on the layer. So winds just moderate light or moderate wind around the 15 knot. And water need to be here, and it's going to push to the cool area. That's the advection fog. Radiation and advection fog understood? Can I continue? Good. And third one is a sea smoke. It's almost the same as a advection fog. It is just a little opposite. There is a ground and there is a water patch as well. And water is still warm, right? And then in the ground, on the top of the ground, there is a air parcel, but this air parcel now it is cool. It's cold air parcel, but it's just pushed by wind, and it just go to the wind area over here. This cool air and meeting with the warm air, so again it start to condensate it. This one we call it sea smoke, because when the warm air, water is getting evaporating, right? Because it's still warm. And in that moment, it's gonna meet up with this cool air, so it just start to having the fog on the top of the water. This one we call it sea smoke. Again, this one also need to have in the winds, also need to have in the water, but it is just opposite way. Good. Another one, which actually kind of we talking about before, it's an upslope fog, or we can say mountain fog. This one, when it's happening, there is a mountain. I'm sorry, this is the mountain, and this is the valley as well. And here, when the air is just heating up very quickly, and then this air is going up, and since this is what is this? So this is air is heating up very quickly. Since this is empty because it goes up, and another air need to be feeding up that area, right? So still here is a cool air during the nighttime. It's still cool. So when the sun is just rising, this land area is quickly heated up, so they want it to go up. Something is empty, somebody need to feed up. When it just goes up, on the way of the going it start to condensate it with the cool air and then warm temperature. So in the middle or the lower level of the mountain, early in the morning, you can just see that sometimes it's foggy as well, right? So that's what we call it upslope fog or mountain fog. And the last one, we call it ice fog. Any kind of fog below freezing level, the water vapor become ice. That's the ice fog. So that one, I'm not gonna write in anything. Any kind of the fog, and then when the temperature is below freezing level, the water vapor, it's gonna become the ice, crystal ice as well, right? And that one is gonna be ice fog. It becomes directly into the ice. That's the ice fog. So we have in the 5 different of the fog, but actually most important things for the theory part and then for your practical part is the first one and then second one, radiation fog and then advection fog. Radiation fog, you need to have in the clear sky, because if there is a cloud, it means the heat is going to be trapped in between. So maybe the land is not going to be cooled that fast. So you need to be in the clear sky, and there should not be no wind, because if there is a wind, it's going to be dissipated very soon. And when the sun is rising, it's going to be dissipated very quickly. But advection fog, you need to have in the advection fog or the sea smoke as well. This one you need to have in the a lot of winds, light to mild is almost light to moderate. Normally they just say that 15 knots. So it's gonna push the warm air over the water, warm air parcel to the cool ground area, and it start to having the fog. But advection fog, it can stay very long. need to be very, very strong wind. It just comes and push them and then dissipating, or another front need to come and then push them. Otherwise, it's gonna stay very long. So when you just start to having the advection force, it start to have it almost 2-3 days. Maybe you might not able to fly because of the visibility is very poor. And basically, this kind of cloud. So as a VFI pilot, we are gonna be trapped inside the fog. So we can't fly sometimes. So this is the 5 different fog as well. Makes sense? Because here is not really clear for the things. So let's just talking about the type of the precipitations. Okay. The type of the precipitation, drizzle, it's kind of mist, but it is kind of the rain. However, the rainwater droplet is very small. It's less than 0.2 inches, if I'm not mistaken. So there is a very small water droplet. That's the drizzle. And continuous rain and then the rain droplet, it is more than 0.05 inches. That one is gonna be in the rain droplet as well. The hail, it's becoming ice. However, the ice it's like in the bowl. When you're having the thunderstorms or cumulonimbus, that area, you are gonna have in the hail. So this is all different type of the precipitation, and there is also snow as well. So drizzle, shower rain. If you guys already you know what is the difference with the shower rain and then continuous rain? Shower rain is just pouring and you just stopped it. Normally we are going to see like a monsoon season, those kind of equator, which has in the rainy season. It just pour all of a sudden, and that moment your visibility is very bad. You can't even barely walk and you can't even barely see. That's the shower rain. And then continuous rain, it can be heavy, it can be moderate, and it can be light. You are gonna see in the next time as well. So there is a heavy rain, heavy continuous rain, and moderate continuous rain, and the light continuous rains, but it's not severe as in the shower rain. Can be, yes. So if it is rain and then the snow, only difference is temperature. Basically, it is all same. If it is outside temperature is cold, it become ice. If the outside temperature is not that cold, it just rains as well. So it can be shower snow. True. So it can be heavy snow, moderate snow, light snow. It can be shower snow. Few days back in Prague, we had in the shower snow for long time, actually for some days. But it's gonna be maybe in Europe. I'm not so sure about those kind of monsoon, the equator area. Shower snow maybe not gonna be that long. It's just like a intermittent. It's gonna be happening. I haven't seen plus shower snow, but I think it can be possible. Because if the shower snow, if it is really heavy, it can becomes with the plus. But as for my experience, I haven't seen it. Normally, I will see this one as well. No. Okay, there is no shower snow. Okay, it's here. So it means it can be, but because I haven't seen it. Where is this UUEE? Guys, can you guys see what is the Nikita send us? This is the things what you are gonna learn next time. If you just see this one here, this is the snow, and this is blowing snow, and later it become heavy shower snow as well, and blowing snow too. Okay, so it means it's very cold there right now. I can see that. So this is how you decoding this one. You are gonna learn later. Next one. So let's just talking about the air masses. So air masses is the air it has some characteristic when you just stay longer period of the certain geographical places. So this air, there's one air parcel or air mass just stagnated, it just stay long in one places. So this air masses start having the characteristics of that area. What does that mean? Normally we just divide it into three: Arctic, polar, and tropical. If you guys can see, this is the place where is the origins of these air masses. If it is Arctic, as you can imagine, it's gonna be very cold, right? And if it is polar, it's not gonna be cold as Arctic, but still it is cold. And if it is tropical, as you can see, the tropical, it's gonna be in the warm. This is the place where this air mass is origins. And plus there is a characteristics, which is maritime and then where it is continental. So you can combine it. If it is Arctic maritime air masses, now it is cold, plus it becomes wet. So when it just comes to some places, it's gonna have in the snow in the winter because it is already cold and it's already wet. It's contained a lot of moisture inside. But if you're just talking about the tropical maritime air masses, now it is warm and it has in the moisture, so it's gonna come with the rain or the mild weather, because if it is warm, still it can just hold the moisture inside. So maybe it can be rain or it can be just normal weather, but which is a humid weather. So this is the origin and plus the characteristics. If it is a polar continental air masses, which is here, this is normally what's going to happen to us. I am not so sure what is showing in the British. However, you can just show to the Central European, like what we can have. It's going to be hot air brings the dry summer, cold air brings the snow in the winter. Right now in the Europe, we having the polar continental air masses a lot because we are cold and it's just snow like in almost 2 weeks now. So when you just see this one, you can just consider what kind of weather characteristic it has. But however, when the warm air masses, any kind of air mass is moving some certain area, it can be stronger and it can be weakening. It depends on where it's gonna pass by. Let's say it just comes to the polar maritime air masses and it comes to the Central Europeans during the winter time. It can be even it can just maintain the polar characteristic, like it can be just colder and colder because our temperature during the winter time it is still cold. So air masses, even though when it just comes to origin, it depends on where it's blowing away, and the characteristic can be changing, it can be weakening, and it can be stronger as well. It depends. Good. So I will just continue. So when you just come to the air masses, and there is a maritime air masses, and then polar maritime air masses, this is a whole air masses. What if this air mass and this air mass is just meeting in the one places? The boundaries, the edge, that one we call it front. I will skip this one. That edge, so two air masses, two different kind of characteristics. Air masses is just come and meet. That's the boundary, we call it front. Why it is not mixed it together? Maybe because the density of the air is the difference. It's like oil and water, so it's not really mixed it. It's just start to meeting each other at the beginning. Eventually, it will mixed. However, when you just met it, still it just having the different density, different character of the air masses. So it's gonna start to having in the edge. We call it fronts. And fronts we have in the 4 different of the fronts, cold front and warm front, stationary front, and occluded front as well. And this is the chart symbol. You expect it. If it is cold front, I'm pretty sure you see it in the news, because in the news, in the weather information, they always say the cold front is coming, warm front is coming, so weather is like this and so and so. That's the things they are talking about. When the cold front is coming, it comes with this ice crystal type, the triangle shape with the blue colors. If it is warm front, it comes with this bubble. And then when it just comes here, when you just see this picture, it means cold front is coming from top to going down like this. And this one is also showing the directions. So this one is going top to down, and warm front is now on this picture is going up from bottom. If the stationary front, cold front and warm front is just matched, but however, it has almost equal power. So it's not moving anywhere. It just stay there for some time. That's the stationary front. So cold front, warm front, it just comes in, and then since it has almost equal power for days or for hours, it's not moving anymore. It just stay on the land area. It means it is a stationary front. Occluded front, there is a one front was going. Let's say there is one front was coming forward. However, cold front is just catching up from the behind it, and then now it is just start to mix it. That one is a occluded front. Okay, doesn't have any picture, so. So cold front is coming. If it's just coming like this, it means cold front is moving like this area. And if the warm front is come, it's normally it's colored, yeah. I just didn't do it. It means warm front is coming like this. And once you just meet it together, and there's no one who is just stronger, and because it is just almost equally is powerful, in these cases, it become, I will just using this color, like this, but it has their own color like this. This is the occluded front. But let's say one front was going for, one front was moving to the east like this. However, there's a cold front is coming from the back. And then since the cold front was faster, so it just catch up. It just met it here because one front was slow and cold front was fast. So it catch up. In these cases, it's gonna be stationary fronts. I'm sorry, occluded front. This is the difference. And then also this one showing in the direction, and then this one is showing in the.
The one that you did first is the stationary front, right?
This one is the stationary. This is occluded.
Ah, okay.
I think I did a mistake, right? I will show this one. I think when I say, I think I made a mistake. This is the stationary, which is just equally mirrored. The one which is just converging by others, that one is occluded. There's no characteristic. Okay, since the presentation doesn't have any characteristics, so let me just starting with the warm fronts. Warm fronts, it's like this. And then when the warm front is moving like this, and then ground surface is here, and then when the warm front is moved, since it is warm air, so when mass is coming like this. Because it is warm, it's wanting to expand it, so it comes like this. And warm front is moving a little slower compared to the cold front. Normally, it is just a slow move. And then normally they say that it is 10 to 25 miles per hour. all of a sudden it just comes a mile, but it's just around, I should say, 7 to 10 kilometers per hour. And it's this one, the warm front, it just comes in, as it just name say, it's just warm. And generally it comes with the humidity, generally, but not all the time, but generally, because warm air can hold more moisture, as we just keep talking about again and again. So when it just comes like this, what's gonna be happen? Since it is warm and since it generally having the humidity, so it comes with the cloud. Okay, I will show. No, this is called the warm air is this one. So warm air MS is coming in. So when the air is moving here, is the warm air is moving this side, as you just see this one. And since it is warm and it has in the moisture, so when you just meeting in the cooler air in front, that's why we have in the warm air. So in front of the front, the temperature can be cooler. It's just saying the colder, you can say cold or it can be cooler. So it just start to condensate in the cloud, very cloud as well. So it just start to having the nimbostratus because it is moisture and it is warm and the air is expanding like this. So when you just come from here, it just start to having the already cirrostratus, altostratus, and nimbostratus cloud is formating all the way to the top of the air masses because it expanded on the top. And when you meet in the colder weather, cooler air, it start to condensate it. Since it has in the moisture and the lower level, it can having in the nimbostratus as well. Make sense? So since it is a cirrus and cirrostratus, you might not have in the precipitations over here, but when you just come to the altostratus and the nimbostratus, you can have in the light to moderate precipitation, light to moderate turbulence, and it's going to be visibility is very bad and all. So imagine if you are flying as a general aviation. I am flying from the Pittsburgh, as this picture saying, sorry for this. As picture saying, from Pittsburgh, I am going to the St. Louis. And this is the weather information, what I'm seeing. When I just departing from here, maybe I can just go higher because since I'm not expecting any lower cloud because this is a warm air. It goes expanded. But if I just go here more and more to the St. Louis area, it means I need to go down because of the cloud is going to be bothering me to come as well. In this case, when I just come and then when I come to the Indianapolis, I start to have in the rain. And if I just come here, my visibility and the turbulence is going to be severe. So in these cases, I'm not going to continue my journey. I either start my journey on the Columbus or Indianapolis, where I can still maintain my visibility and then cloud height. This is the one of the reasons we need to know how to read in the weather information and then what kind of characteristic warm front has it. Make sense for this? Clear for that, guys? Before I just go to the cold air, so cold air's cold front, it comes like this. And cold air is going to be moving faster than warm front. Before the warm front was in the 10 to 25, but this one is going to moving 25 to 30 miles per hour. It's moving quite fast as well. And since this is a colder air, so it's dense, right? It's just density. So it just sneaked it inside on the surface as well. Warm front is expanding like this. Cold front still it is just dense and it become heavy. The air molecules become heavier. It starts to sneak in to the another area. So this is here is gonna be cold out because since it is the cold front behind it. So inside over here, it can be warmer a little bit, right? Compared to this, compared to here. So it's sneaked in. What's gonna be happen is sneaked in. The air in front of us, it can be floated. It can be lifted up because cold air is sneaked in. So air in front of the cold front, it can be floated. Right? So now it started having the form of the cloud, which is the cumulus. Because of that dense air is just sneaked in under the warm air, this warm air mass can go up. And it's gonna be steeper approaches like this to the cold air. So it's gonna be sliding under the warmer air and force this air to be aloft. It can be cumulus and it can be even towering cumulus. And if it has in the if it doesn't have any moisture, it can be cirrus forms, everything. And if this warm air has any moisture, when you're having the cumulus and then towering cumulus, it can be even rain. It means you can start to having the cumulonimbus as well. It depends on the weather in front of this picture. So it can be heavy shower rain or it can be in the shower rain. And if it is cumulonimbus, it can be in the thunderstorms, hail, and lightning if it is possible. And everything can be possible as well. If it is inside over here, the visibility is gonna be very bad. Yes. Is the cloud formed because of the cold front? Yes, because the cold air is sneaked in. Because of this sneaking, the warm air in front of it, it aloft, it lifted up. Because of that's why. So this area you can have in the cumulus, towering cumulus, cumulonimbus. It depends on what kind of characteristic of the air in front of it. And if it is a towering cumulus or the cumulonimbus, it can be heavy shower rain or heavy rain, thunderstorms, hail, and lightning even can be happen as well. And then weather is gonna be the wind is gonna be very gusty. Over this area, wind is going to be very gusty. However, once this warm front, the cold front is past this area, actually your visibility is getting better because there is no reason to having in the cloud right now because it's already clear. It's just pushing it. So once the cold front is passing it, actually your visibility is going to be better than warm front. Because normally it is just cold and then it is a dry air there as well. So only when it's having the rain in front of it, your visibility and precipitation is bad. But once this cold front is passing it, behind the cold front, your visibility is going to be better and then you are going to expecting the better weather than warm fronts. And I will show this one. Here. So this is the cold front is coming. Compared to this one, it's gonna be in the warm air. Since it just sneaked in, the air is just lifting up, so it started having the cumulus cloud. It depends on what kind of weather it is in the front. If it is in the moisture warm air, it can start to having the cumulonimbus over here, since it just pushed up very quickly because of the dense cold air. In this case, this area, your visibility is going to be very bad as well. So as you just see here, this one, it just started having in the St. Louis to the Pittsburgh. So if I just flying like, let's say if I just flying like this, you're going to have in the cloud, you're going to start having the cloud because of the cold front as well. But it's more like in the cumulus cloud, not a stratus cloud as well. But you're going to start having the cloud. But when you just come to here, you can expect in the cumulonimbus. So you really need to check it into your weather informations. If this in front of the cold front having any moisture inside. Because in these cases, we can have in the cumulonimbus. However, once you just pass it here, you can have in the good weather. So either you just stopped your flight over here and waiting to be past it, so you can just have in the nice visibilities as well. Or if you just continue, your visibility can be bad, and then you can have in the very costing weather as well. This is the differences. Continue to the. Okay. If it is if it is a stationary weather, it's just two air mass is almost equal, so you are gonna expecting the whole mixture of the weather. So I'm not gonna explain in detail. Since one front is coming, cold front is coming, and it is almost like the equal power, so you are gonna have in the mixture of the air. It can have in the also nimbus stratus clouded, and then it can have in the stratus, the layer of the cloud all the way of the one front. At the same time, you are gonna have in the cumulonimbus weather, so you can have in the thunderstorm, heavy shower rain, and you can have in the gusting weather, so and so. So stationary weather, actually, it can be really hard to fly when you just see on your weather chart. Okay, Nikita, I think so your voice is something filter. I'm not so sure. Can you write it down, because it's been like this for a few times actually. Whenever you want it down, you can just write it down because your voice is deformed. So I will just show this one first. So the wave front is moved to this year. So warm air is going like this. This one was the warm front over here, and the cold front is coming from the behind as well. If the cold front is moving fast, since it's just moving fast, if it is just like a converging together, it can be occluded front, which is cold front is just going faster, so it can be occluded as well, right? So if you just see this one, you don't need to see it on the upper part that much. If you just see this one, over here, cold front is coming, and just in front of the cold front, air is basically it is warmer than cold front. And if it has in the tropical marine air, if it is maritime, it means it has in a lot of humidity inside. It means you can just have in the cumulonimbus or towering cumulus cloud very quickly because it's warm. So when you just emit the cold front here, it just start to condense, so it can create the cloud very quickly. At the same time, it's humidity, so it has in the nimbo, it has in the water vapor inside. So you start to having in the cumulonimbus clouded here. And inside over here, your precipitation is very high, your visibility is very bad, and you are gonna have in the gusty weather over this time as well. And then behind it, if it is a polar maritime air, since it is polar, is cool, maritime, even though it is cold, it has some moisture inside. So when it comes to the freezing level, it can just have in your cumulus as well. If it is still having the moisture, it can have in the precipitation, or maybe it doesn't have any precipitations as well. It depends on how much moisture inside as well. But when the warm front is moving here, so there is one front is moving, and this one front is going to be warmer than the one in the front. So once the one front is coming, it's expanding on the top. When you just emit it in the cold air, it just start to condense. So cloud is going to be all the way to the top because this warmer tropical maritime air meet the polar maritime air, and since the air is just start condensing because it is in the cold one, so all the way through the front, you are gonna have in the cloud as well. Nimbostratus, normally it is in the stratus air as well because it can be just in the layers. And then if you just have in the, since it is maritime air, when you have it in the clouded, of course, because of the moisture, it can have in the precipitations. Can I check in where is the numbers? No, it's fine. But I'm just wondering where is the number, which numbers you are talking about. A previous picture. Previous picture. You mean this one? Yes, this one is in the pressure. This is the pressure. Trend is 9990, 1002, 1005, and 0038. So it means what does that mean? This is the high pressure and this is the low pressure, right? Mean is going this way. Remember the first day I just said that there is a pressure gradient force. So from the high pressure to the low pressure. So it goes like this. Wind is coming from here. But front is anyway moving to this side. So this is what's going to be happen when you have in the different fronts and different characteristic of the air masses. Cold front, warm front, and then since this side is warmer sector and this is cooler area compared to this one, so stratus of the cloud is coming. If it is lower area, precipitation will be happening with the nimbostratus because of the tropical maritime. And once you just come to the cold front is approaching to us, in front of it, this is the tropical marine air, which is warm and the moisture air as well. Since the moisture air with the cold front happens, it comes with the cumulus type of the clouded, and it has in the heavy rain, so it can come to the cumulonimbus clouded as well. If it is not that moisture, maybe it doesn't need to be the cumulonimbus. It can just be the towering cumulus as well. It has in the moisture inside. What are the jet cores? At the top of the warm front, the places where the pressures need to be moved. That one we call it the jet streams. Whereas the two air masses is moving at the edge of the air masses, there is one circle, like a circling tunnel type of the very fast wind movement. We call it the jet streams. This one is happening more like in the above the 30,000 feet up to tropopause. I'm not really explaining because this is not our syllabus. Because it's a very high position. Normally, it's just happening at the top of the air masses. So normally, it is just around the tropopause area. So this is the places where and the airliner wanted to go with if it is a tailwind. If it is a headwind to go to some certain places, they wanted to avoid it, so they either go below, so they can avoid it. But if it is a tailwind, they wanted to go with this, so it can be faster because the wind on the jet stream can be up to starting from the 100 knot to 200, around the 200 knot as well. It can be very fast, like a tunnel of the winds. Can I continue? So there is a cold front and then one front, and there is a stationary front, and then there is a cold and one front occluded. But occluded front, it's just divided into two. If the behind the cold air is more dominant, where the warm air is dominant. Because normally it is in the cold type, because cold front is moving fast. But since warm air can go as well, so it can just divide into two. So what is the front is behind? So what's going to be in the converging it? That's why we just divide it into two. So in these cases, this is cold air is coming from the behind. So this cold air moving fast, and it just comes and catches the warm front. This is the cold type occluded front. But this one, since warm front is just come and catch the cold front, that one warm type occluded front. This is the two different things. Most of things is the same, but it just depends on where the precipitation happens. Once you just comes in the cold air, just come in this one, again, it just sneaks in. And then the warm air in front of it, it's going to be uplifted. So in front of the cold air and just right behind the warm front, the precipitation is going to be happened. But this one, warm air is going to be lofting as well, right? Because in front of the cold air. So the precipitation is just happening before the warm front, because it just goes up and it's gonna be in the like a stratus type of the precipitation. So it's just happening what's gonna be different about what kind of type of the precipitation and what kind of type of the cloud is just happening. That's the two different things. So this is the stationary front. It has in the cold air characteristic and warm air characteristic. So it has in the or both characteristic it has it, as I just said before. Almost the one of the most important things is about the thunderstorms, what we need to learn. The storms are formed intensive vertical development with the cumulus or towering cumulus. So it needs to be unstable atmosphere. And plus the thunderstorm comes with the nimbus stratus, nimbus clouds. So it needs to be cumulus or towering cumulus cloud and plus nimbo clouded as well. So how is this starting it? You need to have in the convection. Convection means updraft and downdraft force. You need to have, there is something need to push this air masses up. It can be fronts, or it can be high pressures, and those kind of things need to be there. So the air need to be lifted up. Orography means the same. It's kind of mountainous area. When the mountain is here, if there's a wind is blowing, wind is going to be pushed up to the mountain because of the geographical characteristic, because it goes up. So it need to be the orography or the convection. I will just say this is almost in the same things. Something need to be lifted up, and they need to be in the converging together, or and then even in the fronts as well. So front pushed it, like we just said in the cold front is just push it and sneaking, and this is this cold front need to lift it up, the warm air masses in front of it, so it can be uplifted as well. However, thunderstorms has in the three different stages. We call it cumulus stages and the mature stages and dissipating stages. Cumulus stages is the same as a cumulus cloud. It just need to lift it up and this warm moisture air just need to lift it up by convections, orography, convergence, and the fronts, and those kind of power. And in these stages, if you just go this area, it's just having the only updraft, upper air. So if you just in these stages, of course, if you just go to the inside the cloud, maybe there is no precipitation yet. However, you are going to have in the very severe turbulence as well. Thunderstorm can be the 5,000 feet, it can be lower. It depends on the how much updraft air it has it. So it just go up, and so cumulus cloud is happening. Once it comes to the major stages, now there is a uplift force, and at the same time there is a downlifting force. What does that mean? It just go up, and this water vapor and the humidity cannot hold anymore inside the cloud, and it start to precipitate. It start making the precipitation. Is there is some force to be up, and then this cloud cannot hold any more of the water vapor and the moisture. It becomes the precipitation and it goes down. So in these stages, there is updraft and then downdraft as well. That's the major mature stages. And it starts having the precipitation under the thunderstorms. And if it is the dissipating stages, there is not that much of the updraft anymore, because now this cloud cannot hold the precipitation anymore, and it's just making the whole precipitation into the ground as well. So normally this time it's going to be happening in the shower rain, and it has in a lot of gusts as well, and a lot of wind inside. And this is the time you can even have in the hail. It depends on how powerful thunderstorm is. So keep it in mind that the thunderstorm happens And then it's going to be happen with the 3 stages, which is the cumulus, mature stages, and dissipating stages. If it is a cumulus, there's only uplift forces and it start to form. So in this case, it's better avoid it. Don't go to the top because we don't know how fast it's going to be happening. So stay away, avoiding as well if it is cumulus clouded. And once you just come to the mature stages, why I just say major? Mature stages, there is a uplift and then downlift as well, and then precipitation is going to start happening. And then it's going to go really up. I just said that before, it can be even with the tropopause. It depends on how powerful uplift force is. If it is a dissipating stages, there's not that much of the updraft anymore. It cannot hold any more precipitation. So it's going to be dissipating as a precipitation. It can be heavy rain, and it can be even hail as well. And the lightning things is going to be happening in these cases. Normally, they say from the cumulus stage to the dissipating stage, how long it's going to take it? Around the 15 minutes. So it's going to be happen very quickly. So as a VFY flight, since you need to observe the outside, how fast the cloud form. So if you see these kind of things, if you can avoid it very long distance, very far, in this case is good. If you can't, for some reason, in this case, you better land before you enter in this effective area and wait until it got past it, because it's going to pass very quickly. Clear for that? Because general aviation, we can't hold this updraft and downdraft inside it. That's the thunderstorm. So thunderstorms, turbulence, because of the updraft and downdraft. Icing happens because inside there is a full of precipitation. So if you just go inside, because of the aircraft is flying quite fast, we can have in the icing as well. Hail and lightning and the pressure difference affecting the altimeter, because inside there's a huge pressure differences. So your altimeter is going to keep fluctuating because of our static port is going to be sensed the different pressure. So you can't really rely on the altimeter which we have it if you have any chance to go through. So you can't really rely on your altimeter. So you need to be careful. And then again, the last one is going to be in the microburst. But before we go to the microburst, I wanted to talking about the wind shear. Let me just check it out. Okay. Wind shear, but before that, let's just go through this one, different type of the turbulence. Turbulence, okay, no, I'm sorry. Let me go to the wind shear first. The wind shears is a sudden and significant change of the wind speed or directions. It's going to be vertical and it can be horizontal as well. So wind shear, there is a very strong movement of the wind vertically and horizontally. It's not really wide area. It's very small distance, small narrow area happens. So if you just go inside of this wind shear area, you are gonna encounter a lot of different kind of the wind inside. First, still there is a very strong vertical downdraft. So if you just having the climbing at this moment, you're gonna increase the headwind because there is a lot of wind is coming from toward us. So you feel like your aircraft performance is very good. But the moment you just passing here, if you just come here, you're gonna have the very strong tailwind. So when you just climbing in this area, since you feel like there is a very strong, very nice performance the aircraft had because of the increase of the headwind, maybe you are gonna play with the power. You just reduce the power a little bit because feel like my aircraft is perform very good. But once you just pass this one here, you are gonna start to having the tailwind. You are not gonna having the headwind anymore. So you are gonna quickly losing your attitude. This is what is happening when the wind shear is happening. What is the difference with the wind gust? The wind gust is more, it is horizontally, horizontal movement. It's the same, like a same level, strong and weak, stronger and weak. That's the wind gust, which is different with the steady wind. But my wind shear is there's a vertical movement as well. So you are gonna feel in there's air which is gonna push you to the ground. So imagine if you are around the ground level, maybe you might not be able to come up. So there is a horizon and vertical movement, and then normally it just comes with turbulence and the thunderstorm, especially if you are below the thunderstorm cloud or towering cumulus cloud. Clear for this? But what is the and there's another type of the wind shear which is the microburst. But what is the difference? This one microburst normally it just comes with a very strong thunderstorms. But difference with the microburst and wind shear there is a horizontal movement as well. But microburst is a very strong downdraft only. Only the vertical movement only. And then places where you have in the microburst is even more narrow. So only around 8 kilometers area. So when you just having the major or the dissipating storm at the bottom of this one, you can have in the microburst, which is very, very strong. Mountain airfield, yes, it is. And the wind shear can be happen anywhere actually. So, so of course, in the big aircraft, big jet aircraft, they are equipped with a wind shear detector. But since we don't have any those kind of equipment, if ATC is just informing us there is a wind shear in vicinity of the airport, you better not taking off. You wait. You wait until it just passes it because it's gonna be removed very quickly. It's gonna be dissipating very quickly. So you just wait and until it just passed it. Once you just passed it, you can depart it again. That's the best option. Because if it is just happening like this, when you just having the climbing, you might not be able to overcome. So wind shear is a horizontal and vertical movement, and then it comes with the turbulence and the thunderstorm, as we just talked about it. Microburst, what is the difference? It has in the strong downward draft because it can be a little confused. If it is on final, if you can go around, of course, if you are coming in. Because you don't know what kind of characteristic or what kind of effect you are going to have when you are doing that, when you are approaching. What if you just come to the short final, it just push it, and in that case, you can't overcome. You better go around and then come back again because it's going to be dissipating very quickly. Normally, they say it's going to be last only 5 to 15 minutes. So 5 to 15 minutes later, you just hold it somewhere, and then you can just come back in again. And as you can just see that it is 6,000 feet per minute. So it means 1 minute you might lose your altitude at 6,000 feet. So imagine how strong it is. Because normally our approaching the rate of descent is 500 feet per minute. So it's gonna really push you on ground very quickly. So if there is any controller, which is just to say the microburst and wind shear, you either go around or do not taking off. And then waiting for the another information, it's already dissipating. So that's the microburst over here and the wind shear, which is a hazard with the thunderstorms. So let's talking about the turbulence as well. And turbulence is basically it is updraft and then downdraft movement vertically. That's the turbulence. And if it is a thermal turbulence, which you are gonna have in a lot if you come to our training in Europe. And thermal turbulence is happen. It's because of the radiation heat from the sun. So when you are just flying like this, and the sun is just heating up the ground, and it just start having the radiate the air masses. So the air masses below the aircraft and above the ground, it just keep rising up by radiation from the ground. So you are going to be updraft and downdraft a lot. It's because of the thermal turbulence. So what's gonna be happens if you are just flying like a vegetation area at the end of the afternoon, because it's gonna absorb a lot of heat at the end, so it's gonna push in a lot of as well, right? But at the beginning, let's say if you're just flying early in the morning, when you're just flying over the vegetation area, maybe you're not gonna have that much turbulence compared to the road or the land area, because the road and land, they are gonna absorb the heat very quickly, and they start pushing it as well early in the morning. But at the early in the morning, maybe vegetation area is not gonna be that much the heated, because they haven't absorbed yet that much. So you just flying here, and then over the road and then land area, you just start having the turbulence. But when you just flying in the vegetation area or the river area or the ocean area, you're not gonna have that much of the thermal turbulence, because it haven't absorbed that much heat yet. So it's not releasing yet. This is gonna be happen. But what about the late afternoon or in the evening? What's gonna be happen? The road and the land area, it's not gonna have any that much thermal turbulence, because they already released all the heat. But when you just fly in the vegetation area or the warm area, that time you are gonna start having the thermal turbulence, because it start to release the heat as well, which they just collecting the whole entire days. This is gonna be happen for the thermal turbulence. Orographics and the mechanical turbulence is just happening because of the frictions, which is a man-made obstructions. Sometimes you just feel that when you just go to the city, which is having a lot of building, between the city, you feel like the wind is very strong. It's because of the friction. It can't just go as it is. It just need to fly over it. That's why it start having some turbulence as well. So this turbulence is just happen when you just near to the hangar in the airport facilities, because airport facilities, you just stop the air to flowing smoothly. So when you just come to this kind of area, you are going to start having the very strong wind because of the friction. So you just need to be careful for that. And then, so this one, another one is in the cloud turbulence. The one which just talking about before, the cumulus cloud, and then those kind of cumulonimbus cloud. If there is a cumulus, if there is a cloud, it means under the cloud there is some obstructive force. That's why the air passage just goes up, right? So under the cloud, you can always expecting some turbulence. Especially if it is a cumulus, it's going to be even more turbulence, because there is more force is going to the up. That's the cloud turbulence. And clear air turbulence, it's going to be in the higher level of the tropospheres, which is I just talking about before, which is the jet streams. And there's no visual sign, because this one is basically happening because two different air masses is just hitting it. So it doesn't have any that much visual sign, and it is too high to having some cloud as well. So it doesn't have any sign, and it's going to be in the higher level, and it comes with the jet stream as well. So if you're having the tailwind to go to the destination, normally this is what the airliner does, and they want you to go with the jet stream so they can go faster. But if it is just coming back, if it is heavy, of course they can't fight with this wind, because wind is that strong, that tunnel. So they always choose the lower level and then come back to the destinations. This is normally happening for the clear air turbulence. And let's talking about the icing. Icing happens even though the temperature is not the 0 degrees and below. It can happen even though the temperature is above the +°C. It's because of the aircraft is move faster. So when the aircraft move faster, pressure is getting lower in front of it, so temperatures get lower. So aircraft start having the icing on the fuselage, or especially the leading edge or the leading edge of the elevator, the forward part of the elevator. Let's talking about the clear ice first, because clear ice is the one which is very dangerous for us as well. Clear ice is still happen when the aircraft is flying the cloud, or aircraft is flying the cloud as well. It doesn't need to be in the precipitation inside. When it fly in the cloud, it has in the moisture inside as well. Even though it is not a 0 degrees and below, even though it is just around the 5 degrees, so when the aircraft is going inside the cloud, the precipitation and the moisture just hit it, and the moment it just hit it, it's just going around it as well because aircraft is moving here, and it started having the ice because of the pressure differences. Lower pressure here, so temperature is getting lower, so it started to form the aircraft. It started having the ice over the wings. And this one, it is not safe at all because this one might stop the aircraft configuration. Maybe aileron is not going to move it, or maybe elevator is going to be stuck because of the ice as well. So this is one of the dangerous ice we can encounter when it comes to the icing of the aircraft. And the problem is, since the precipitation doesn't need to be there, precipitation, visible precipitation doesn't need to be there, so we don't even know that there is ice on the cloud, there's ice on the wing, but it can be happens when you're just flying through the cloud. That's the clear ice. And so it can be dangerous because it can be stuck on the wings, so it can be stuck with our aileron and the elevator, and plus it can add weight of the aircraft. It can increase the weight because ice is quite heavy. So our CG point, if you guys remember, center of the gravity point can be changed. So we can't really guess in our aircraft configuration at the end. Rime ice, it's happened when the aircraft is flying through the air, which is already having the ice inside. So the ice crystals, ice pellet is already held inside the cloud because it is already freezing level. When the aircraft is moving, it just start to come and stick to it. So this one we can already forecast it because the temperature is lower. It's going to be in the less than 0 degrees, like a freezing level, 0 degrees and then less. So ice crystal is already present inside the cloud. So when it just come and it just attach to it, it's already there, so it's just stick to the wings. That one is the rime ice. If it is dangerous, yes, it is dangerous. But I just say the clear ice, since we can't forecast it, we can't see it, it can be dangerous as well. And this one is also same. It can increase the weight of the aircraft as well. Permafrost is just happen because of the zero surface comes into the contact with the moisture air. So aircraft itself, it is already cold when you just flying for a long time in the cruising level, and then when you just start to descending, the frost can be happen. This is what you normally see when you just having the cold winter in the morning. So normally this one is just happening through the descending and then climbing when the temperature is just changing very quickly. So during the cruising, we just flying for the long period, very cold weather, cold temperature. So our aircraft surface is already very cold. So when you just come down to the warm surface area, the warm air, the moisture inside the warm air just start to condense on the top of the aircraft. That one is gonna be happen. So this is the one different type of the icing. However, as a VFR flight on our aircraft, we are not allowed to fly in the icing area if you don't have any de-ice or anti-ice equipment. You can't fly. We already discussed about it. Microburst, we already discussed about it. And then volcano ash can be happen. I think so around 10 years back it was happening, if I'm not mistaken, in Iceland. It's just happening for the few months. Once it's just happening in the volcano ash, and it's gonna be the whole the meteorological condition can be released for the aviator. What's gonna be happen, as you can see that it's gonna be the decrease the visibilities, and it's not only the dust. There's a lot of small particles of the stones and dust and sands and those kind of things is all moving around for the long period of time, like a days, even month, And not only the visibility, and those kind of the particles can damage the aircraft as well. And plus, the gas which is released from the volcano, it can be toxic and it can be smelling gases, so you need to be careful. And plus, if those kind of particles or dust can go inside the engine, and it can be damage the engine performance, or even engine can be stopped. So that's why if there's something happen about the volcano, that area, airliner or even the general, we are not flying. Do you guys remember the like a 10, I think it's almost 10 years ago, there is Iceland volcano in Iceland. And then I think it's a few, I'm not saying few days, few months back in Indonesia, there's a volcano is also happens. When you see these kind of things, if you just open in the meta and that area, you will see the information about the volcano. Normally, we don't really encounter, but it also still is going on, especially the equator in Indonesia and Japan, and I think even on the Philippines area, still there is a live volcano, so you can also encounter these ones. Almost there. So the last one is gonna be in the mountain waves. It's part of the turbulence and then cloud as well. Once the wind is coming to the mountain area, it comes with the oscillation. It comes with the wave because of the geographical characteristics. So it's just having the wave like this to the lee side. And when you just, if you just see the any theory book in the lee side, is this area. This is the lee side, L-E-E, downwind side, lee side. So once you just wind is coming from, because of the geographical characteristic, it comes with a wave like this, right? And it's just to start having the disturbance of the weather, the airflow. When it comes to the disturbance of the airflow and the higher level, it's okay, still there is a wave, but at the below level, the turbulence is just start happening a lot. So if your aircraft is coming to like this to the upwind, if it is low level, you can encounter quite strong turbulence in the below here. Cool. However, at the upper part of the mountain, since there is a wave and the wave is oscillating, if you just see the lenticular cloud, like this lens shape of the cloud, you expecting that there is wave of the turbulence, and below the lenticular, the lens type of the cloud, you can expecting the turbulence as well. So if you just come toward the mountain area with upwind, expecting that you are going to have in the turbulence, if you can, you better go up higher and then fly. Normally, if you just comes to the airliner, they say they are just choosing the 5,000 feet above the mountain. Oh, you're in the Mexico. This is what's gonna be happen. So if you can, any mountains area, if you can go that higher, normally the airliner and the general aviator, if you can go higher, they just choose the high altitude, which is normally they say the 5,000 feet above the cloud. So you are not gonna have in the that much turbulence, and you don't need to even go through the precipitation or the cloud as well, because if there is a cloud, it means it can have in some turbulence inside as well, right? And however, if it is below, you can expect in the turbulence as well. It's because of the disturbance by mountains. Clear for that? So this is a different type of the cloud, lenticular cloud. But it comes with the mountains area. It's more like in the turbulence explanations. Good. Sorry not to have it in the break. I just wanted to finish it quickly as well, on time. So let's just go through our open tasks. And before that, I am opening the attendance sheet, so you can just do the attendance. I am not so sure it is working or not. Can you guys click the attendance if you have anyone who has things? Because actually it doesn't have any notification for me, so I'm not so sure it is working today or not. Normally it has a notification. Guys, can you check if you guys can press the attendance and then your link? Got no access, not a problem. Not a problem. I also stay figuring out why we don't have any. It's here. This is the link. Okay, let me try once again. I opened it. Attendance. This one is today. Because normally it said it's open in the 15 minutes only, but today it's not showing. So I'm not so sure it's because of the internet connections. I don't think it's open. Is there anyone who can do it so far? Because there's a few students who is using it actually. But I think so today because connection was bad, so it's not happening. Not a problem. Later, when you're just starting, when you're just ending it, let's just please type in your name so I can just do it as well. Okay, let's just go for this one, humidities. I know there is a confusion part of the humidity and saturated air lapse rate and dry air lapse rate, that thingy. I think so you guys are confused. Okay. This is quite. Let me try again. So my name. My worksheet is stuck on the last question. I think so, you know what? Maybe because of the screens, the internet before. I wish I know something about knowledge about IT. It's a Friday night. I don't want to go. I don't want to hold you guys more than 8 o'clock. I have nothing to do though. Right? Okay, let's go for this one. Mine is, nothing is opening yet. I can't hold it anymore. Can you see my things, my questions? Let's do it here together. Is that okay? Let's not wasting our time anymore. Good. So difference between temperature and dew point. What is it? Good. Let's go for this one. Difference between temperature and dew point is greater in what? For me, personally, it doesn't make sense of the air with the low temperature, air with the high temperature, because there is nothing which really makes sense, right? So either it is dry air and then moist air, correct? If it is air plus it is moisture, it can't go up that much because it's getting heavy. So dry air can go up more and more and more and up and up. So answer, I will go for the dry air. Oh, okay. Oh, I'm so happy, guys. You guys getting it. What about this one? This is one of the things you guys was confused. a layer of the atmosphere is absolutely unstable? Absolutely unstable, it's because the air parcel can go up more and more. Why? How do you guys know this? I'm so glad. It's because more than 3 degrees per 1,000 feet. So it can go, if it is absolutely unstable, it's just go more and more and more because outside the temperature is colder than the air parcel. So air parcel can go up, up, up more. Very good. What about this one? The layer in which temperature remain constant with the height? Oh, actually, this one I didn't explain. One thing. Can you guess? Temperatures remain constant. Neutral. But, okay, in weather, there's no neutral. It's either stable, unstable, conditionally unstable. Okay, one thing I didn't explain, I'm sorry. This is one thing I haven't explained yet. Let's say like this, there is a 15 degrees Celsius, 13 degrees Celsius, 11 degrees Celsius, 11 degrees Celsius, 11 degrees, no, and then 11 degrees Celsius, and somehow this day it become 12 degrees Celsius, 12 degrees Celsius, and then all of a sudden it become 9 degrees Celsius. It can be happen. Normally, the air, when you go up, temperature need to be decreased. That is true. But someday it just happen when you just go up, temperature is going up and stay like this. This area, we call it inversion. We call it inversion layer. Why it is happen? Let's say during the night, it was cool. Here, the ground surface was getting very cool somehow. But at the early in the morning, warm air was there, and then it just getting warmed, so it floating it. It didn't make in the fog and nothing. It's just floating it more and more and more. It just goes up. But again, it's not the air temperature is not enough. It's gonna be stuck in some certain layer, which is not far away from the ground. It cannot be go up that high because the air pass is not going to have any that much energy since they are just using in the very short period of time of the sun radiation heat. So it's going to be very closer to the ground. However, the air, even though you go up, it's either remain constant or it's even getting warmer. So we call it inversion layer. This one, it's not going to be good for it's like you need to thinking about when you just having this kind of the inversion layer when you're flying it. Imagine you are approaching like this. You are going down like this. You have in the cold air, so your aircraft is performing good, so it just comes down again. And when it just comes here, all of a sudden there is a warm air. So your aircraft engine is not gonna performing very good compared to before because there is a less dense air is going inside the engine. So your aircraft is getting less efficient. Your engine is getting less efficient. And when you just passing it again, so if you don't do any action, when you just passing it again, you are gonna having still the less efficient engine. What about when you're climbing up as well? If you are climbing up, let's say you're just climbing with the full power and your climbing is okay. When you're getting up, your temperature is getting cooler, it's going to be dense air, so your engine is going up very nicely. The moment you come to the inversion area and then if you want it to climbing, still that thin part of the layer, air is getting warmer, so climbing rate is going to be less than before because of the warm air inside. And since this is a warm air inside over here and the air is not going anywhere, here the visibility is gonna be poor, normally because of the haze. This is what is happening when you have in the inversion layer. your engine performance is gonna be changed. It's gonna be less efficient because the air comes to inside the air engine. It's gonna be less dense, and then plus your visibility is gonna be bad. What's gonna be happen about the stabilities? Imagine when you just having the warm air and then it goes up and up and up like this. And since this is a layer which is blocking the air is moving it, it's not really going through it. So when you have in the inversion layer, below it there is the air circulation. However, this inversion layer it just work as a fence. So air cannot really going through here as well. So this one's make sense, guys, for this? This is a place where temperature is stopped decreasing, or maybe it can be even increased as well the short period of time, where it just remain constant. So when you just having the rear flying, because it's happening a lot, if it is really rear flying, your engine is getting less efficient because less dense air comes inside the air, especially when you're climbing. You just see that your climbing rate is going to be getting less because of the less dense air. And the visibility is going to be bad as well because this inversion layer is working as a fence. It's like a wall. Good. So this one's I will go for that is absolutely stable because air cannot go through. Air is just staying under the inversion layer. So absolutely stable, if you can understand it. Can I continue? What about this? Latent heat is released emits. Just thinking about it, when the air molecules is releasing the heat and gaining the heat. When the water vapors become liquid, when the ice become water, it's released the heat, right? When water wanted to be a gas, it need to have a heat to be gas. You need to switch on the gas stove to boil the water, and it's gonna be the water vapor, right? So latent heat is released when it's gonna be released. Liquid to gas? No. Thinking about it. Liquid to gas, you need the heat. You need to observe the heat. That's why we are switching on the gas stove, right? And then solid to gas, same. When the ice you want it to make in the water vapor, you want it to switch on the stove gas. You need to put it in the heat to be gas. But okay, let's go for this one. From here, if I want it to have in from here's ice to water. I'm sorry, ice to gas. I need a heat, right? Ice to gas, I need a heat. Ice to water, I need to heat. Something need to be melted. I need a warm temperature. I need to heat. So from here to here as well. From I wanted to put in the gas to the solid or gas to liquid, I don't need a heat. I need to give my heat so I can be in the ice or I can be a water. Make sense? From here to here, I need a heat. Imagine when you're having the ice to water, water to gas, you need the heat. So that's why the what is that? Snow is melting. That's why the water become gas. But if I just wanted to make in the water to ice, I need to make it freezing. I need to remove the heat. Wow. Okay. So liquid to gas, I need a heat. Solid to gas, I need a heat, right? Ice to water, I need a heat, so it needs to be melted. So it was where it is, gas to liquid. Understand this? Just thinking about our normal life, ice and water. It's very easy questions. Heat need to be released, where I need to observe the heat. Good. So it's not complicated questions. Indeed, because there is a heat release, the thing is, it might be a little confused, but it's a very simple question. Like thinking about water, ice, and water vapor, the gas as well, the water vapor. When you boil when you're making the tea, basically, when you want it to have in if you just wanted to make in the ice to the water to ice, I need to give away my heat. Water vapor to the ice, water vapor to the water, I need to give my heat. But if I wanted to make ice to water, ice to water and vapor, I need to have a heat to be warm. So this is all about that one. But it's not that hard questions at all. If you're just thinking about water and ice. What about this? Temperature and dew point less than 1 degree apart. Okay, question is not really completed. On the ground surface, let's say the ground surface, and then temperature and dew point is very low. So ground surface is just 15 degrees, but dew point is 14 degrees only. It's very close each other. It means you can have in the cloud anytime at the very lower spaces because this moisture, the air pass doesn't need to go up that high. It's gonna start to saturate it already. So it can be fog or the low cloud as well. This is good. What about this? If you remember, if it is a clear night and flat land, calm, very good. Thank you so much, Miss Briers. So if it is a clear night, calm, there is a calm, light mean just consider there is no wind. It's just a calm mean there is nothing. So it means the land is gonna be cooled down very quickly. So whichever the air mass is on the top of it, it just condensated at the below very quickly. So that's why it start to having the fog. So it's a radiation fog. Very good. What about this? Advection fog. It has it's not really important maybe. I mean, important means when you come for the flying wise, because fog is a fog anyway, but for the theory, it has in a lot of questions regarding advection fog and then radiation fog. Or maybe for the flywise, it is also important because advection fog is gonna last for long, some days. Warm, humid air over the cold surface is very good. I'm sorry, very nice. Very good. So advection fog, you need to have in the warm, humid air, and then we need in the water, and then cold surface as well. If it is opposite, that one is gonna be sea smoke. Warm, what is that? Cold air comes to the sea area. That one is gonna be sea smoke. Good. What about this? Some of you guys was confused for this one. Octa, it is just a unit like a pizza slices, because we are going to divide into 8. If it is 5 to 7, and I told you to be careful, it's not a 5 to 6, it's a 5 to 7. Very good, it's a broken. Nice. And then, this is like a cotton type of cloud. Nimbus, it comes with the rain. Cirrus, feather-like. Cirrus, maybe I can say this is, it can be cirrus or cirrus stratus. It can be feather-like a cloud. Nimbus stratus is gonna be layered, dark gray layer where we just see a lot during the summer. So this one is gonna be cumulus. Good. What about this? It can be cumulus, right? Because it's kind of layered, it's covered everywhere. So I will go for the something stratus. Good. Cumulus is cotton shaped, broccoli. Remember? So it's not a broccoli, it's a layer. Layer comes with the stratus. So you need to find something with the stratus. And nimbo possible because it's a dark gray which comes with the rain. So that's why this is the nimbostratus. I will go for that. Guys, getting it, these combinations? I know it is a very hard word because we are not, this kind of terminology we are not using as our daily life. I got to know this word when I just started my PPL. But if you just know the combination, it's going to be super easy. You don't need to worry about it. And then nobody is going to ask you to spell it. I still don't know the spelling, if I just, to be honest. What about this? Let's go for this. Cirrus, feather-like. Right? So it can be. Cumulus, possible, because it's cumulating. Right? Stratus, possible. However, there is a cumulus as well here. So cumulus possible. Stratus possible here. But can you just see that there is a cumulus and then there is a dark gray, what is the dark gray, the blanket type of the clouded together? I will go for cumulonimbus clouded. Very nice. This is how we are doing it. You understand this? It's very easy. Nice. Let's go for this one. This one? But the cumulo clouds is indication of instabilities in atmosphere. Good. That's why it's just going up and up and up. Presence of the warm air is aloft is also correct as well. It can be passed. I'm not saying the correct, but it's a conditionally correct. But molly cumulus is just happening because there is a force is coming up. So it's an instability in the atmospheres. Because it doesn't need to be warm. It doesn't need to be warm air. It can be even in the cold weather as well. I mean, it doesn't need to be really warm. If it is any air which is just pushing it up, if it is instability, it can come up. So answer can be more accurate answer here is instability in the atmosphere. This is more accurate. Guys, let's just go for the 4 more questions and then let's just finishing up. I know I'm sorry to be late, but I want you to guys know this. What about this? Remember, the air masses acquire its basic properties. Where it is originated? If it comes with the polar, if it comes with the Arctic, if it comes to tropical, where it is originate, and then the air masses need to stay there to have a characteristic, because if PL is just moving away, it's getting weakening and stronger, getting very fast. It doesn't have any characteristic that much. In air masses need to have in the air, need to stay that position for some time to gaining their properties, dry, wet, warm, dry, warm, wet, like this. And then it's going to be spreading into the other properties as well. So very true. The answer is this one. You need to stay there for some period to having the properties of the characteristic and then going to another places. Good. What about this? Something is coming up. Cirrus, cirrostratus, altostratus, nimbostratus. It just comes all the way. This is the sequence. What do you think, guys? But it comes with the cirrus, cirrostratus, altostratus, nimbostratus. Okay. Aisha's saying something different as well. I will show this one. When you just come to the cirrus, cirrostratus, altostrat, nimbostratus comes because warm air, always remember, it's expanding on the top. It wanna go on the top. So when the aloft, because it's expanding, because it is warm, and then one is just meeting in the cold air in front of it got condensated quickly. So when you just starting from the cirrus, cirrostratus, altostratus, all the way up the front, it has in the cloud, and at the end, it just comes with the nimbostratus. So it is a warm air. If it is cold air, so everybody's saying the cold fronts, because cold fronts is just quickly having the cumulonimbus cloud first. Because this dense air is too quickly lifted up this warm air aloft. Guys, can you understand these differences? So this one is the answer for warm front. Clear? Good. Two more questions. The cloud type of the most applicable for most squares 2A, 1A. 2A and 1A here. 2A, if you have this kind of question, 2A, 1A. And this is the cold front. Very good. CB. Very nice. Remember this picture? 2A, 1A. So this is the places where it need to be. This end and this one. Very nice. What about this? The last two questions. Cold fronts compared to the warm fronts. I mentioned it once. Warm front is slow. Cold front is faster. I give you the one thing. Steeper and faster. Shallower and slower is warm front. Just read the question clearly. Cold front compared to the slope and speed of the warm front. So what is asking cold front characteristic? It's a steeper and it goes faster. Very good. So answer is steeper and faster. Good. Thank you very much for the classes. This is all what I prepared. And please do write in your name because our attendance sheet is still not working, I guess. Oh, or guys, can you do it again? Because now it's just starting it. I just saw it. If you can click it, please do click it. If you can't click it, it's fine. Just write in the name. Not a big problem. And then those three students, Mr. Otabek, Ms. Breyer, and Mr. Sunat, I'm gonna say about you guys a link as well once again. But however, bear with it for the patience. And then thank you very much for the classes. And then Next time it's gonna be your weather information, how to decoding the weather information from the service, and you are gonna do it on the Monday together. Thank you so much. Have a good weekend, and I'm sorry for the overshoot for the 20 minutes. Thank you.
Thank you.
So much. Bye. Thank you for the patience. Ciao, ciao. Bye. Hope to see you soon again. Come to Prague anytime. Bye bye, guys. Study well. I'm sorry, I didn't know that my mic was on mute. Mr. Collins, you can unmute the mic and then you can ask me the question. I'm sorry. I didn't know that my mic was on mute and I was talking alone.
Okay, okay. Yeah, there was a calculation I was trying to solve yesterday from what
Which one was it?
yeah, the calculation about the okay, I got it. Look, should I send it to you? See it? I think I should perhaps um give it to you. So it probably help me solve it.
Okay, your voice is very echoing. If you are not so sure, you want me to ask about the Q&A and QFA and the thingy?
Yes, yes.
Okay, I got it. I will come back. Just wait a second. You can mute because your voice is very echoing for me.
Okay.
Let me just go for it. Let me find it. Where is my presentations? Okay, I can't find it. Okay, I'm sorry, I can't open in the right now. Okay, let me just check it again because today internet is very bad. What's wrong with today's presentation? Is this about this one? Good. Okay, so I will just explain once again if I'm not mistaken, and then please stop me if you just don't understand things. First, altimeter is the one who's just checking the outside pressure and it's just calculating it. And there is a three difference pointed. If it is a QFE, we report ourselves height. If it is Q and H, we report ourselves altitude. If it is Q and E, we report ourselves is a flight level. And then otherwise we call it also pressure altitude. It's the same thing. Q and E, it's a fixed thing. It's a 1013. It's a fixed one. QFE and QNH is all the time changed. How do we change it like this? Once there is a mean sea level and there is elevation of the airport. When the aircraft is here on ground pressure, we call it QFE. If I am on ground, if I set my altimeter on QFE, my height is 0. But at this moment, let's say this airport elevation, we call it, this one is elevation of the field from mean sea level. Elevation is 900 feet, let's say. In these cases, when I put my altimeter with the QNH, what's gonna be with it? 900 feet. I'm in the same position. I'm not going anywhere. But when I put the QFE, I put the 0. I read the 0. When I put the QNH, I'm gonna read the 900 feet. This is what is happening. So in this moment, let's say my QNH is today is a 1020. This is my QNH. Question you can ask then, in that case, what is my QFE? When my QNH is 1020, I can calculate it because this is just a calculation. My altimeter is also doing the same. In this moment, when you are in the center of the gravity, your pressure is high, right? This is the first thing. Pressure is high. If you go up, your pressure is getting lower. So QNH is 1020. If you go up, the number of the QNH is gonna be getting less. The number is getting smaller because the pressure is getting lower. That's the one thing you need to keep it in mind. And starting from here, according to the pressure differences, 1 hectopascal differences is to 27 feet differences. What does that mean? It's a one hectopascal. Okay, if it is 1000, is a ground here. It means 27 feet. 998 is a 54 feet. 997, we call it 27, 81 feet, like this. So since it is hard to use it, let's just do it approximately 30 hectopascal, 30 feet. So here, airport elevation is 900 feet, divided 30, it means it's 30 hectopascal differences, according to compared to my QNHs. It means I'm getting higher, pressure is a lower number. What is gonna be my QFE? It's gonna be 1020 minus 30 hectopascal. It's gonna be 9990 QFE. Let's do another one. I'm not so sure you understand or not. Let's go for this one. Airport mean sea level, airport things. Airport. My aircraft is here. Today, this one is, let's say, 1,200 feet. My airport elevation is 1,200 feet. Today, my QFE here, they say, controller say that pressure of the airport is 998 hectopascal. In this case, what is going to be my QNH? Can you calculate it? You can unmute. Let's try once again. You can unmute, maybe. You can if you unmute, maybe. I'm not so sure you understand it or not.
Yeah, I'm getting it. I'm getting it. I'm following.
Okay. Take your time. Mr. Abdullah, just for your information, class is over. I am just doing the after classes for the questions, so you can be out. 997. Why? But imagine QF is a 998. If the QNH is a 997, don't you think 1 hectopascal difference is only? I don't think so. Let me go through the once again. These questions. What is my QNH? First, 1,200 feet. If you just convert it to the hectopascal, 1 hectopascal, it's a 30 feet. Correct? So 1,200 feet, how many hectopascal? If you divide it into 30, it's going to be 40 hectopascal. One hectopascal, 30 feet. It means if it is 1,200, you need to times 40, right? So it's going to be 40 hectopascal. So here is a QF is a 998 and difference is 40 hectopascal. And since we are going to the center of the gravity, pressure is going to be higher. It means the number is going to be higher. So 998 plus 40, it's going to be 1028 hectopascal. Let's go for another one. Here, let's say it is a 600 feet elevation. Airport is here. QFE and QNH. My QNH today is 1013 hectopascal. What is going to be my QFE? Let me calculate it because I haven't calculated yet. So it means 600 feet divided 30 is 20 feet. It means 1013 minus 20 hectopascal. So 9, 20. What is it? 3? 9, 3, I think. Oh, I'm sorry. 1013. Yeah, minus 20. What is minus 101? Nine, 3. Yes, you got 903. Very correct. You understand this part now? Because 600 divided 30, it means it's a 20 hectopascal differences. Because 1 hectopascal is a 30 feet differences. Hectopascal difference, we go up, pressure is lower, so number is lower. So 1013 minus 20, 993 hectopascal. You got it? Last two questions. What is my QNH? Last two questions.
Niner
9090. Basically, let me check this. So 300 divided 30 is a 10. So it means I'm going down, pressure is getting higher. So 980 plus 10, 9090. Very good. You understand? Now?
Yes, I do. Just one more question.
I'm happy for you. Any other questions? What is the ISA pressure and flight level? Oh, as far as I'm not so sure what is the exact number. I don't want to be mistaken, but it's a half. So I think it's a 550 hectopascal. But to be honest, I don't remember the exact answer.
Can you explain it?
I know that flight level 180, it is a half pressure from the grounded. So I think it is a 550.
Can you explain it?
ISA standard pressures. Wait a second. Okay, let's do it. Let's see. You mean the standard pressure, right? So
Yes.
1 hectopascal difference is 30 feet, right? So flight level 180, it means it's 18000 feet. Correct? So 1800 feet, this is the feet, and divided 30, it means 600 hectopascal. So in the standard condition, ISA condition, mean sea level is a 1013 hectopascal. If it is a flight level 180, we are going up, pressure is getting lower. So 1013 minus 600, it means 413 hectopascal. According to this ISA condition of the calculation. I'm not so sure you understand this one. Do you want me to repeat?